Hello and a very warm welcome to our programming for today. You're watching Tech Days, a developer's guide to AI. Our program will begin in just a few minutes with our cloud advocate, Amy Boyd. In the meantime, here's what's coming up today.
Hello and a
Welcome to Microsoft's Tech Days series. Today we're discovering the Developer's Guide to AI, hosted by our Senior Cloud Advocate for AI, Amy Boyd. Over the next 2.5 hours, we'll see demos and presentations from our global team, and we'll be meeting tech community leaders, customers, and Microsoft partners from the UK and Europe. Now, before today's show begins, we'd like to talk to you about our code of conduct and our commitment to accessibility. First of all, code of conduct. This is a virtual event, and we ask all of our presenters and guests, whether appearing on screen or participating in live chat, to be aware of others, welcoming and respectful, to be understanding of differences, to be friendly, patient and accommodating to others, to be open to all of the questions and viewpoints, and most importantly of all, be kind and considerate to others. If you have any concerns about anything you hear or see in today's show, please email buzzcond@microsoft.com. And now a note on accessibility. If you require captioning today, please watch the show on Microsoft Learn TV at aka.ms/LearnTV. After today's show, you can find all of the links and resources from the show at aka.ms/techdays-AI-resources. Now, don't forget that we have live chat throughout today's show. We have a small team of moderators answering the questions, and during the live conversation elements of the show, we will answer your top questions on air live. We'll also have a panel towards the end of today's show, so keep asking your questions throughout and we'll answer them at the end. Now, without further ado, let's introduce our host, Senior Cloud Advocate for AI at Microsoft, Amy Boyd.
Hi everyone! Oh my goodness, what a fantastic introduction for today's event, Tech Days, a Developer's Guide to AI. As it's already been mentioned, my name's Amy Boyd. I'm going to be your host for the next 3 hours, so strap yourself in. We have so much exciting content for you around the area of AI. And so what I wanted to do straight from the start is kind of set you up for what this event looks like, who we're going to talk to, as well as how you get the most out of this event. As we can see, we're all at home. I'm here in my office space at home, and we are bringing this to you online. We're so excited for you to join us. And the Developer's Guide to AI is really for anyone out there who is in a technical role, potentially a developer, who has been thinking about AI technologies and services, but also has been kind of looking in and going, oh, like, how do I get started? Or even sometimes that question of, where does this AI apply? Where does this service get used? What does a use case look like? And I hope for the rest of this session, for the next few hours, you're going to be able to get those questions answered. So the Developer's Guide to AI is a set of 5 sessions. So we have 5 15-minute-ish sessions that will basically deliver that inspirational why. Like, why should I use this service? Why is this AI service useful for me and my business, or a project that you're working on, for example? And then from that why, being able to then dig into any questions that you have. Now, in this session, we have some incredible experts. So we're going to have 6 different experts. We have a team of experts for our 3rd session. Here it is, our amazing agenda. You might have spotted it just at the start there. So we're just doing a little introduction right now. We'll then jump into a session based on computer vision. So these sessions, AI, ML 10, 20, 30, 40 and 50 that you can see on there are all pre-recorded. They have been created by some of our amazing content creators from around the company that are actually going to show you things from computer vision to text and audio processing, We're then going to look at making sense of unstructured data using Azure Cognitive Search. We'll move on to the exciting area of conversational AI. And then finally, at the end, we'll jump into that element of, okay, we've looked at kind of pure developer AI. How do we start moving across those boundaries if you're interested in learning more about data science? And as you'll see underneath each of them, we have an interview for around 10 or so minutes to get all of your questions answered. So we'll be talking to Willem from our global AI community and also Microsoft MVP, James Mann, software engineer and MVP for AI. We also have Kekila and Adelina, who Kekila works for BP as a lead architect and Adelina as a cloud architect at Microsoft. So we're going to really dig into a great use case there. We also have Gary Pretty, Senior Program Manager on the Conversational AI team from our engineering team, joining us for that question and answer session around chatbots. And then finally, introducing Marta. Marta is actually a program lead at White Hat, which is a data science training company, and she's going to tell you a lot more about that. And then what we'll do at the end is we'll bring back all of our great experts and we'll continue that conversation around learning, resources, culture changes inside organizations. So that's our agenda just there. The key things I want to kind of chat to you just before we jump into our first sessions is, how do you get the most out of this? So as we said, we're going to have these pre-recorded sessions. They're the key, like some key content, the technical demos, etc., that are there ready for you. They've been really well rehearsed and polished, etc. And then when you're watching them, think of those questions that immediately come to mind. Don't hesitate. Put those questions into the chat and our amazing moderators will answer some of the questions, but they will also pass some of the live questions over to myself and I will have the opportunity to ask our live experts to answer it so that everyone can benefit. So it's that time-old saying that we say, if you have a question, there's many, many other people in the audience that are probably going to have exactly the same question. So please do keep engaged with us. It really makes this event an exciting community to take part in. And also, I do believe you'll get the most out of it as well. Everyone is potentially new to AI here, and that is what we've kind of designed it for as well, for those who are getting started, for those who are wanting to learn more. So no questions are silly questions. Every question can be answered, and we definitely have a team of people available to do that. One of the other things I just got asked to mention as well is if you are watching this via our Microsoft event pages, there is a main Q&A section. Please add your questions there. If you come across this feed on any other platform, for example, Twitch or Learn TV, do go to aka.ms/techdays-AI, and that's where you can join in to ask conversations. We will be monitoring that space, and we have lots of people waiting there for you. So let's get started. We have talked a bit about code of conduct. The Developer's Guide to AI is all about introducing you to Azure AI services. And in this first session, we are going to talk a little bit about introducing computer vision for automation in changing times. And our speaker for this is Anthony Bartolo. He is a senior cloud advocate at Microsoft. He specializes in the space of IT pros, and so he is not necessarily, he wouldn't deem himself necessarily an AI expert. However, he has been doing some incredible projects in the space of computer vision. And so without further ado, let's roll the video.
Hey everybody, Anthony Bartolo here, Senior Cloud Advocate with Microsoft. And today in this session, we're going to be introducing computer vision for automation in changing times. And we're going to see a couple of things run through on this presentation today. We're going to walk through a business challenge and see how applying the data science process helped this team solve said challenge. We're also going to see how the Azure AI platforms and tools can support you when you're solving your own business challenges. So let's begin. AI, the magical beast that everybody wants to rub under their business and either try to save money or make money in harnessing it. This is one of the challenges that a lot of organizations face. They hear the whole premise and promises that AI brings to the table, but don't know how to properly harness it. Some don't even take the step back to say why AI is being implemented into their solution, and that poses another challenge. In this scenario here, we're going to explore the core participation of AI in an opportunity to address a business challenge. It's the ability to do so to allow for businesses to take advantage of these tools without the complexity that's there. Using tools like machine learning workbench and cognitive services and the APIs that have been created already give the ability for organizations to easily create proof of concepts, to implement thoughts and ideas to address opportunities that lay ahead of them. One such opportunity that utilized cognitive services to address a proof of concept was when Microsoft partnered with a company called Indra Robotics based out of Canada to identify individuals in the water when a ship has been reported in distress. Prior to, emergency services would be sent out to the area to survey the area to see how to best help the scenario and obviously help those victims that are in the water. Now with the drone, you'll have precise knowledge of what the occurrence is in terms of the emergency, and knowing that there are individuals in the water, then reporting back to say, this is the services or this is the emergency that's in front of us that needs to be addressed. So the Coast Guard would be more proactive in terms of saving of individuals as opposed to not knowing what the scenario is when they get there. What's great about this solution is that we have the full write-up in terms of how the solution came to be and the steps to accomplish this made available on aka.ms/drone AI. Now, using that same learning and that same technology, what we're going to do is we're going to take this and apply it to something else. In this scenario here, this is the website for Tailwind Traders, who is a hardware retailer. The Tailwind Traders website has many of the usual e-commerce features and the ability to browse the entire product catalog, order products online, and find products in retail stores. But it also has a few AI-enabled features as well. As you may have guessed, Tailwind Traders is a fictitious company, but that means that I can give you all the source code to deploy this app yourself, and you can find it in the link at the bottom of the slide. The biggest challenge that Tailwind Traders is currently facing is they have a situation where they need to take inventory of all the items that are inside of their warehouse. This requires optical confirmation of the hardware or devices that they're going to have to count for inventory, which is a one-by-one process. The challenge with this, especially in current times of the pandemic, is that social spacing is required, and so the amount of staff that takes the Tailwind Traders to do the inventory is going to be a lot less due to social spacing requirements. So how do we incorporate artificial intelligence to understand quantities of hardware that's inside of their warehouse to help solve the challenge of having less people do the actual counts of inventory? Now, this is the 15-minute session in regards to the delivery of this presentation, but I did want to call to attention this great blog post that was put forth by Cassie in regards to how to create a learning model in less than 10 minutes. In the upcoming demo, we are going to create a manual model for Custom Vision AI to understand differences between tools. Cassie's solution here allows you to build out a full-scale model to teach Custom Vision AI the differences between specific hardwares or specific objects in less than 10 minutes. This demonstration will be carried out in a full 45-minute presentation of this delivery, but I did want to call visibility to this blog post, which those that are watching this video can replicate in order to create their own model in 10 minutes. So as mentioned, we're going to go forth and create a cognitive services model to understand what we're looking at to do hardware counts. And we're going to be using the same technology we use with the drones. In this scenario, we're not going to be identifying life jackets. We're going to be identifying tools to help Tailwind Traders do a count of inventory with less staff. So first we start off by setting up the model, and to do so we're going to go visit www.customvision.ai. This is the workbench that we'll be using to identify different types of hardware and tools for inventory purposes. So first thing we're going to do is we're going to add images. And so here are the images that I've captured doing a Bing image search of a hammer. We know this is a hammer because it has a long handle and it has a blunt object at the end. Some hammers have the prise at the end that allows us to pry items open or take nails out of wood, so on and so forth. Teaching Custom Vision AI requires us to import these images into the workbench and label them as such. So we're labeling these as a hammer. Now to add to that mix, because Tailwind Traders has more inventory than just hammers, we're going to add wrenches. And so as you can see, we know that this is a wrench. We're going to add this image now to the workbench, and we're going to label these as wrenches. With the hammers and the wrenches now labeled, what we will do is we will train the model, and that'll be done by clicking the green button up top. That will now allow for the Custom Vision AI to analyze the images and the labeling attached to those images to recognize the differences between a hammer and a wrench. Now the Custom Vision AI goes through its iterations of understanding the differences between the images and comes out with a precision, recall, and AP totals in respect to understanding the differences in terms of the shapes and identification of said hardware. This is important because now you have the logic that can distinguish between a hammer and a wrench. With this compute now completed, we now have the ability to take this model and export it. As you recall from the drone proof of concept, the ability to have the drone identify a life jacket in the water required the drone to be self-aware of identifying life jackets. Because the drone itself were in areas that there were no connectivity, it had to have the logic and the capability to understand what it was looking at. In this scenario here, taking the logic that we've now taught computer vision AI the ability to extract said logic and import it into a device to make it intelligent in understanding what it's looking at will help inventory processes, because you'll have these devices that will be self-aware in terms of what they're looking at and provide quicker availability for counts. So the logic itself will be exported into an Onyx file, and we export it into an Onyx file only because this is an open source logic set that allows us to take this existing model and import it into a device to make it intelligent on the edge. So we'll export the logic file as an Onyx 1.2 file. And in this scenario here, what we'll be doing is we'll be incorporating this logic file as a model in Unity for the ability of a HoloLens to have that capability to recognize objects. So in this scenario here, the workers will be wearing HoloLens devices to look at inventory to do counts. If you want to look at the Unity file that incorporates this model for the identification of tools, you can go to aka.ms/wirelesslife. So here's an example now of the HoloLens recognizing objects. In this example here, the HoloLens is not connected. It has the ability to identify objects, but there is no connectivity to the HoloLens itself. All the logic on the HoloLens resides on the HoloLens and doesn't require connectivity. This is what we call edge computing, the ability to have a device have cloud-like services, or in this instance, recognizing of objects without connectivity. This comes into play when you're in scenarios like a warehouse where connectivity may be a challenge due to concrete walls and what have you, and having the ability to have a device be self-intelligent in the task or purposes it's trying to accomplish. As mentioned earlier, my name is Anthony Bartolo, Senior Cloud Advocate with Microsoft, and this presentation was introducing computer vision for automation in changing times. Should you have any questions, feel free to reach out to the team, and we'll be happy to assist. Thank you for your time.
Fabulous. So big thanks to Anthony. I think it's actually very, very early where Anthony lives right now, so he's probably not watching, but we'll thank him for it later, for talking to us a little bit about some of the use cases he's in around drones, and also how you can use both custom vision, but extend it and actually start talking about those edge computing devices. And so hopefully you are sending your questions into us via the Q&A panel on the Microsoft event channel. And whilst you're doing that, I would like to introduce Willem Menters, who, in his own words, designs software architectures for data and AI solutions by day and runs the global AI community by night. So hi, Willem. Thank you for joining us.
Good afternoon. Happy to be here.
Good stuff. No, thank you so much. I know you are very, very into computer vision, so we're really excited to have you here to speak both a little bit about what you've been doing, as well as answer any of our audience questions. So first things first, tell us very briefly a little bit about yourself and what you've worked on in computer vision.
So during the day, I normally work on cloud computing software, mostly Kubernetes, that sort of thing. But I've also done a lot of work in computer vision with the help of students from Dutch universities. One of the things that I've worked on is anonymizing videos. One of the problems that we run into in our work is that we want to use computer videos from security cameras for various things, but you can't really use those videos directly. So we figured, well, why not remove the people in the video and replace them with 3D models that are just gray people, don't have a face, don't have a particular height or gender, and that make the video usable again for other purposes.
That's fantastic. Goodness me. I was going to say, so that's like another use case. Anthony mentioned, obviously, being able to detect life jackets, obviously being very bright objects, hopefully, in something like the sea, but then also applied it to our favorite of all fictitious retail companies, Tailwind Traders. And we talked a little bit about kind of being able to detect different tooling. And then you're kind of saying that actually, so I'm assuming that computer vision then detects the people and almost takes the bounding box, takes it out and replaces it with something as well?
Yeah, we're trying to first find out where the people are in the video. So that's depth-wise and also in X and Y axes. And then we try to segment the video in such a way that we can very precisely cut out people. As you can imagine, you could do it with a rectangle. That's the first step that we took as well. But then we started looking at how can we very precisely segment the pixels in the video, detecting this is part of a person and this is not part of a person, and then cut out the pixels and replace them. It's actually a combination of a number of models, so it's actually more of the advanced application of computer vision.
Yeah, I was going to say, well, levels of it, let's talk a little bit about that. So we saw there customvision.ai being used, which is an incredible service in the sense that if it's right for your use case, so image classification and object detection can be used in custom vision, that can just, you train it on like, what, 20, 30 images? I mean, how much 10, training 50? Data? Yeah, so it's really a lot, enough to just try it and experiment with it. I'm guessing in a more bespoke scenario, did you have to use a lot more data than that?
Yeah, we had to use a lot more data than that, several terabytes of data, to be honest. Yeah, that's a lot more than the stuff that you put into custom computer vision. Custom computer vision starts at 10 images per class if you're doing classification, and a bit more when you are trying to detect objects. The funny thing is, out of the box, it works really well. Even with a few images, it will start doing amazing stuff for you. And that's because they base it on existing models that are pre-trained on a large number of objects in the real world. So the computer sort of knows what to look for, and you actually tell it, well, I'm not just looking for any car, I'm looking for this specific car. And the same for Anthony's case. I'm just not looking for any object. I'm looking for a spanner or a hammer.
Yeah, no, exactly. And so actually, that was when we used to have events in person. And that was when people at the end of a session, if I was talking about computer vision, would maybe come up and they'd be like, oh, can I use it on this specific use case? And I'd be like, go try it. Like, you only need a handful of images. Then the more variety of the images, the better inside custom vision. Talk to me about the difference between, because a lot of people here might have heard of Azure Cognitive Services computer vision, and now we're talking about Azure Cognitive Services custom vision. Can you break those two down for us?
Yeah, so when we start looking at the computer vision solution in cognitive services, it's a general purpose model. So it works on a few thousand different objects. It can detect a wide range of things. It works in a typical scenario. So if you're going to try this out, I would start with that. It's a lot faster. You don't have to do any data gathering. You don't have to develop anything yourself. You just call the API, and it works out of the box. The downside to that is that it is general purpose, so it might not work for your case, but you do have to try that out. If you run into an issue where it doesn't detect the object that you want to find in the image, then you're going to have to switch to custom computer vision. And custom computer vision, these are based on the same types of models that the cognitive service version uses, but you can customize them. And it makes them a lot more powerful. So you can say, well, I'm not interested in a few thousand objects. I only got 10. So you upload the 10 different images, and it will start detecting that instead. Also, what's also important is that the custom computer vision you can run on the edge. The general purpose one you can't run on the edge because it's too big, actually.
Ah, interesting. Okay, so now you bring some of my sort of one of the other things that I was thinking about when I was listening to Anthony, edge computing. So you've just mentioned there the size of the model, and obviously Anthony was showing the HoloLens and all of that amazing stuff as well. So can you talk to me a little bit about how that works? So from custom vision, it becomes a containerized model, I think was the words that we used.
Yeah, so basically what you do, you train the model on the website, and then you can download the model as a container or in any other format. There's a number of formats that are actually supported. So I happen to have an instance open. I can show you. Let me pull up my screen.
Nice, yeah. We're going ad hoc and we're screen sharing. How exciting.
Yeah.
Here we go.
So I happen to have a small sample model that I developed for another case. So instead of recognizing tools, we're recognizing Simpson puppets in Lego form.
Fabulous.
And this is all pre-trained. And what I can do is I can download this model, and I hope I'm in luck today. Yeah, I'm in luck today. So we can download the model. Let me quickly pull it up. Oh, it's failing all over the place. Oh boy. Let me see if I can find it anywhere here. No, it's not working for me today.
No problem. I think when you create a new one, right, you have to choose a specific model for it to be trained on. So it's called transfer learning, isn't it? When we have a model behind the scenes at Microsoft, and you build sort of that last level of filters. Yeah,
that's what happens. So it's a neural network behind the scenes that's being used. For those not familiar with the neural network, it's a model that uses stacked layers of neurons. It's a very complicated mathematical formula that we're trying to optimize to detect objects and images, classify data, that sort of thing. And what you can do is you can pre-train that model in full with thousands, millions of images, and it will be really good at detecting a wide range of different objects. But it won't be very good for your specific case because you've got bad lighting, maybe the angle is wrong, that sort of thing happens. The computer is only able to understand similar images. So if you have an image that's very different, it doesn't work. But there is a trick you can use here. You can use transfer learning. Basically what we do is we cut off the final 2 layers of the neural network. Okay. We'll throw those away. We never look at them again. Then we'll add up 2 new layers, and we block the first set of 100 layers of the neural network. these image networks can get very, very large, millions of different parameters that are being trained by the computer. And basically, we say to the computer, well, skip training the first 100 layers. I know those are good, but focus on the last 2. And then it will quickly learn how to recognize new objects because it knows what a doorknob is, it knows a right angle, a diagonal angle, it knows what a texture is, it understands color, those kind of things. And then it combines those features from the image, the rough objects, into the final result. That's basically what it's trying to learn.
Fantastic. So we have some questions flying in, Willem. This is the test of time at this point. Always the bit we worry about as experts, right? So one of the great questions that's come in is, how do you teach the computer vision model that an image is not what you want? So a toy car opposed to a real one is the example. So how do we say that's not what I want to know from custom vision?
Well, in all honesty, you can't. There's no option to tell the computer this is not a real car. The only option that you have is if you build a model to detect cars, to classify, maybe it's an Opel, maybe it's a Mercedes, maybe it's a BMW, and then you put in a toy car, it will put them in any of those categories. It doesn't understand that it's a toy car. Yes. There's a trick to it. You can introduce an extra category. I usually call it none or undefined. And I add images to that are classified as something else. I basically tell the computer, this is nothing. I'm not interested in this. And by training the computer to recognize those images in the none category, you're basically saying to the computer, this is not a BMW, this is not a Mercedes, this is not an Opel car, this is something else. And that's the only way. It's just a trash bin of your neural network in that case.
Yeah, I was going to say, and I think in custom vision, I've not used it in a good couple of months, but I think it's called the negative category, which is kind of like none, like you were saying. And so that negative category is like, and everything else in some sense is like, it's not what I'm looking for. So that was a great question from the audience. Thank you so much. Keep them coming. Willem, they are flying in. I'm trying to keep up here. This is fantastic. Like, thank you for sending them. It's worse when it's super quiet. So there's some stuff about pricing. Can we talk a little bit about pricing? So first of all, when we're using the computer vision API, what are the costs associated there?
I don't know by heart, but there's 2 options in this case. You have the paid option. You pay a small fee per request, but you can fire off a lot of requests. And there's the free option. It's limited to a number of requests per minute. I believe it was 30 or something. Yeah. And that's great for development and trying things out. So do start with the free option and then upgrade as you go. It's not that expensive, to be honest. So.
Yeah, and fantastic. Our producer, Adam, in the background, working his magic there. So aka.ms/azcalc is the Azure pricing calculator. And if you choose the Azure Cognitive Services, then computer vision or custom vision, it will drop down and you can start estimating your costs. Another one associated with that, Willem, is bringing things to the edge. And what are some of the costs associated with that? So is that free? So do we just then like give you the model for free?
Yeah, that sounds awesome. If it were that easy. No, it's not free. So you're paying still per request. And there's a catch here that so you can disconnect from the internet, but after a while you have to connect your edge device to the internet once to upload the usage of your model. So no, it's not free, sadly. But again, it's not too bad. Just keep in mind that if you're going on the edge, you sometimes every once in a while, every few weeks, I believe, you have to connect to the internet and upload the data files. That's all done automatically, by the way, so you don't have to think about it all that much.
Yes, I was going to say it's literally like the only API call it makes in some sense, isn't it, to send back usage data. We are unfortunately at time, but we have a question on the screen. Oh, Adam, bring it back up. We'll go on. We'll take this on. Does the image resolution play a part in image recognition? Does the background color play a part, for example?
Yeah. So larger images will be more difficult for the computer. Compressing them down will remove the details of the image, and that will, in many cases, help identify the objects in the image. Again, it depends on what you're doing. If you're trying to recognize a broken bone in an X-ray image, then details are important, and you shouldn't compress the image.
That is fantastic. Willem, you have been a superstar answering all of our different questions there. We are going to hear from you later in our panel as well, where we'll talk a little bit more about global AI community. That's towards the end of the session at 2:45 GMT. But yeah, thank you so much, Willem. Thank you for joining us and answering all these tricky questions, especially about pricing. So fabulous. So without further ado, we will go into the next session. So we've covered computer vision. We're on to text and audio processing, in which we are going to have a presentation that is called Extracting Value from Text and Audio to Inform Business Strategy. And that is delivered by the amazing Amanda Wong, who is a cloud solution architect here at Microsoft. So let's see the video.
Hi, everyone. Welcome to our second session of the day, Extracting Value from Text and Audio to Inform Business Strategy. My name is Amanda, and I am a cloud architect at Microsoft. And today we're going to learn how you can use Azure to add speech and language capabilities to your business applications. Our use case today is an online retailer's customer support center, but the concepts and tools you'll learn here today will apply to many other scenarios as well. Let's get started. So the customer service center we want to improve belongs to Tailwind Traders, an online retailer for a variety of home appliance and DIY services and tools. Like online retailers across industries right now, Tailwind Traders relies on call centers and online agents to deliver excellent customer service. However, with everyone at home during the pandemic, the demand for improvement tools have skyrocketed. So while this means business is good, Tailwind Traders has also seen a growing number of customers calling and emailing for help. If any of you have had the experience of contacting an online company recently, you know it can be a real pain to resolve something as simple as a return. So customer service at Tailwind Traders is something they want to optimize and use business insights to scale more quickly and drive their business forward compared to their competitors during the pandemic. Enter Azure Cognitive Services. So with AI, we're going to improve Tailwind Traders Customer Center to automate the support processes and help them learn from every single customer support ticket. This can ultimately help reduce costs, identify areas for product and service improvement, and overall improve customer satisfaction. So to do this, we'll be going through how to use Azure to store massive amounts of structured and unstructured data, analyze that data using Azure's text analytics service. And finally, we're going to create automated support workflows with logic apps and extract valuable insights from PowerBI. The customer support tickets for Tailwind Traders come in two forms: phone call recordings and emails. This poses a complication of storing both types of data and analyzing them together. On the one hand, you've got unstructured data, which you can think of as the most common data types around us: photos, PDFs, recordings. It's tricky to have a machine read these consistently. In fact, we have a great session right after this working on unstructured data, so make sure to stick around for that as well. Structured data, on the other hand, is a lot easier to deal with. Structured data is a lot more database friendly. You can think of emails from customers being sent in as a great example of structured data. But instead of having separate storage options for unstructured and structured data, we're going to make it easier and simplify the process by using Azure Blob Storage. With the holidays coming up, there might be a spike in requests for returns or general customer inquiries. No worries, Blob Storage can handle it without a problem because it scales really easily. So let's see it in action. Accessing Azure Blob Storage is incredibly easy with Azure Storage Explorer. You can navigate to the Blob container for your project, in our case, Tailwind Traders, and upload the file from our local machine. It's pretty simple. You can, of course, use the API or SDK for Azure Blob Storage, but this is a pretty beginner level tool to get familiar with Blob Storage. And so what we're doing here is checking that our new data source, our new phone call transcripts and emails have been uploaded correctly, and that looks great. So now that we know where we're putting our data, the next step is to analyze the text and extract insights. With Azure's Text Analytics API, we can take in call transcripts and emails and analyze them for sentiment, extract key phrases, and identify proper nouns. Sentiment is an amazing tool because it can help us determine customers' outlooks on the company, whether it's positive, neutral, or negative. We're going to use it today to see where customers are having the highest negative sentiment. For example, which products and services may be attached to the most complaints or points of feedback from customers. The next offering we're going to use with the Text Analytics API is key phrases extraction, which will help us gain a high-level insight of what customers are contacting us about. And finally, key entity extraction takes that a step further by identifying specific product names and services, and potentially even pure company names to provide valuable insight for our business model. So this is just a drop in the bucket of what the Text Analytics API can do. We highly encourage you to check out the full offerings on the Azure portal to see what it can do for your business application. So let's see the API in action. We retrieve our data that we just uploaded from Blob. You can see here, this is the original ticket data with the date created, whether it's been escalated, even the region. And on the far right, you can see the text from the phone call transcripts and even the emails. So we wrote a simple Python script using the API. And when we run that script on the data, it outputs another CSV file that looks the same as the input data, except on the far right as two new columns, key phrases and sentiment, that outputs the analysis for every single customer support ticket. So we said earlier that we wanted to create a more intelligent customer service center. Now we're going to build a machine learning model to predict what any incoming support tickets are asking for help about. So if someone's asking for problems about delivery, we can direct that inquiry on the back end to a specific team to deal with the logistics of that and close that case out much more quickly. Azure's Language Understanding Service, or LUIS, is a great low-code route to train and test a natural language understanding model. With LUIS, we'll be able to classify any new incoming support tickets based off of some business interests and areas that we are concerned about as Tier 1 traders, whether that's pricing or product feature recommendations or trouble with installing a new tool. So being able to filter calls and direct customers to get the right help can really improve the customer service efficacy and efficiency. And you see here on the slide that a couple key terms for using LUIS are entities and intents. Entities is very similar to the key phrases portion of the Text Analytics API that we just saw. It provides the significant metadata from textual input. And then we also have intents, which highlight the underlying purpose or goal of a user based on some textual input. Training a custom model with LUIS is pretty accessible through the online UI experience. The interface here, you can see some of the business areas or intents that we're interested in, design, features, reliability, and a lot more that we manually labeled through the interface. When we go into design, you can see an example from a user asking about whether or not a hammer is ergonomic, which may be important for some folks stuck at home right now. We labeled this manually, as I said, through the interface, but you can upload a data set such as a .csv file into LUIS using the API or SDK. And here's another example, some feedback about the quality of a dining table. This all serves as the training data that we will use. And so once we train that and publish this along with the other intents that we've identified for LUIS, we can give it a test utterance, say a new support ticket asking about help with installing a bathtub. And so LUIS is going to think, and it spits out that the intent of this statement is related to services with a 0.873 confidence score. So now we're going to use two more apps to take the call center to a more advanced level. Logic Apps, and Power BI. Logic Apps is going to use the predictions from Lewis to optimize the customer center's response time to users. Logic Apps is a no-code way to automate workflows by connecting some apps that are critical to your business. For our purpose today, we're going to be linking Outlook, which will look for any incoming support ticket requests from customers and connect it with Lewis to produce the prediction. Logic Apps will also direct the support ticket original email to the proper support team on the back end. Once we streamline the workflow for our customers' agents, we can aggregate and visualize these insights with a business intelligence tool, Power BI. A Power BI dashboard can make it easier to understand what's happening at a higher level with the data and share it with key stakeholders, such as leadership or product team. And we'll see in a moment exactly what you can do with a custom Power BI dashboard. But first, let's take a look at Logic Apps. In the Logic Apps Designer interface in the Azure portal, we've set up a 5-step workflow where a function gets triggered when we receive a new email. We pass it to Lewis to get the prediction, unpack the JSON object, and send a reply to the customer. You can also use plugins like Adobe, GitHub, and Outlook, depending on your business need. So let's see how this runs when we create a test customer email sent to Tailwind traders. We're going to ask for help about a kitchen sink not being delivered yet. With mail services being a little bit slower these days, that's understandable. But on the back end, when we jump back into Logic Apps Designer, we can see that all the steps were triggered, green light, and on the customer end, we receive an email from Tailwind traders with the correct analysis that we were asking for help with delivery speed. Remember what I said about learning from every customer support ticket request? Well, our Power BI dashboard is going to help us dig more deeply into some specific product questions that we are concerned about with Python scripts. So in the top left visualization, you can select different regions, such as the UK. And below it, you can filter for positive, neutral, or negative sentiment. And the key phrases that we pulled from the Text Analytics API will also populate. If you don't want to use a custom Python script, you have options for built-in visualization, such as a word cloud, where you can select different words and the rest of the visualizations will populate. If you prefer to view this data quantitatively, we've pulled the 3 business intents that have the highest negative sentiment for closer examination: service, price, and speed concerns, for example. And within each bar chart, you can see the word frequency associated with each category. For example, services, you can see that a lot of requests were related to refunds. With price, there were a lot of requests related to discounts and more. So we could even take this a step further and analyze which products are being mentioned and associated with different key phrases and sentiment.
Fantastic. So big thank you to Amanda there, who delivered such a great message. She's so very good at delivering those concise architecture messages. So we'll talk a little bit more about that in a minute. However, I would like to introduce James Mann. James Mann is our next expert up. He is a software engineer and AI MVP at Zamo. So hi, James. How are you doing?
Hi, Amy. Hi, everyone. Yeah, I'm good. Thank you.
Good, good. We already have questions flying in, which is amazing. But could you tell us a little bit about yourself and the text or audio projects that you've been working on?
Great. Yeah, so I'm a software engineer at Zamo.ai. And at Zamo, we make it easy for customers to get on voice platforms and chatbot platforms. So things like Google and Alexa in terms of voice, and then in terms of chatbot, there's a bunch of channels we support, web chat, Facebook Messenger, and things like that. So it's a really interesting role I have there because I get to use a lot of cognitive services, a lot of bot framework. I get to apply some of these really interesting things that we just saw about.
Brilliant. I was going to say, in fact, we are going to hear from our colleague Gary Prissy later on in these sessions, and he's going to talk about conversational AI. But I think a lot of the questions and the ideas that have just come from that session will potentially relate to chatbots as well. So I'm glad we've got you here for that.
For sure, yeah. There's certainly a lot of overlap. A lot of the services you make use of for conversational AI, you also can make use of standalone as well. So yeah, fantastic.
Amazing. So let's jump into the questions, the exciting bit for the experts in the room. I am also obviously here to support us on answering some of these. So first question, does text analytics understand not sentiment? So something's not bad or something's not great?
It does. Simple answer, yes, it does. Under the hood, the way it's trained is on a bunch of negative and positive utterances. So typically when something's not good, not great, those not values have a weight that kind of move it towards the negative sentiment.
Yeah, and I guess like over time things are all improving as well, and also just thinking a little bit, obviously things like sarcasm are a little bit more so,
Very difficult.
Yeah, and like the phrase "not bad," like someone always, like whenever I join a call or something, people are like, "How are you?" I'm like, "Yeah, I'm not bad." Do you know? I don't know what that is.
And it's very cultural as well, isn't it?
Yeah.
It's someone English says "not bad," they usually mean good, but someone American says "not bad," and it's usually negative.
Yeah.
So that comes into some of the issues with assisted AI in that it's not 100% perfect, so you need to be mindful of. It's an assistive technology, right? It's not there to make a decision. It's there to guide you to make that decision.
Yes, that's a really good point. And really anything in machine learning, right? It's kind of giving you a probability back. It's giving you what I like to call a point in the right direction, hopefully. And yeah, so that's a great one. Thank you everyone for sending in the questions. We have a few more. So can something like cognitive services deal with synonyms for keywords? So if you ask for help, assistant, I need something.
It can, and it very much depends which cognitive service you're using. If you're using something like Lewis, for example, which you saw in this session, Lewis has a thing called list entity types. And a list entity type is a way you can almost kind of pre-train your Lewis model before it's actually looking at the utterances. So you could have a bunch of synonyms against that particular word, and then that kind of enhances the Lewis model. The other cognitive services, for example, search, there's certainly ways you can specify this. So when someone provides a search query, those search queries are kind of translated into, they're normalized effectively, so you get a consistent response. I guess the big point there is there's a bunch of different ways you can handle it. Yes. So maybe, I don't know if we can send a few links as a response, just to kind of give you a list of things to work through, and you can see which one would be particularly relevant to your use case.
Yes, so I'm sure our fantastic moderators are already on it, but a call out to the moderators. We need kind of the text analytics documentation sent, as well as Lewis. Lewis is going to be a key one there, I think, for understanding synonyms and that kind of relaxed, probably not the right word, flexibility of language, right? Lewis is very good at that. Okay, what else do we have? Speaking of languages and flexibility, there is an example here that says what languages are supported by some of these. Now, I'm going to take this one. There is some amazing documentation out there. If you type into your favorite search engine, text analytics, Azure text analytics languages, it will be the docs page that is likely to come up at the top just there. And it will list for every single cognitive service that we have in the text space, which languages are and aren't supported. And I guess James, a bit like our other piece, right? Go try it out. There's a free tier for all of these.
Definitely. And, one of the things that I kind of just wanted to recap on the first session is these things are really easy to use and and play around with and see if you can get some value from them. So certainly, if you have an hour or two just to investigate, you can pretty much do your POC in that time and work out where the if there are any gaps or if it meets your need exactly.
Fantastic. And there we go, Adam saving the day again in the background. Language support documentation is at aka.ms/techdays-ai-langs up. That's a nice one to say out loud. Cool. So, let's talk about a bit about voice, James. Are you comfortable with a little bit about voice as well?
Yeah, certainly.
Great stuff. So what about voice recording? Can that be converted for Lewis?
Yeah, I mean, you have a few options here in terms of how you want to consume that information. I can actually give you a specific example that we've used ourselves, and that's taking effectively an audio recording that we get through a voice channel. So a customer calls in and says something, and we need to take that content and convert it into text so we can understand what the user is asking and maybe pull out some entities and make a decision on that. So to do that, we actually use the cognitive search services speech recognition. And again, it's really easy to consume. You just basically there's a few different ways you can do it, but you point it at a media file and it goes away, and it takes half a second, comes back with the text. And then once you have that text, you can send it to Lewis or sentiment analysis, whatever you need to do basically to understand that text and make decisions from it. It is worth mentioning that technically it's really super easy to do, but as soon as you're dealing with information from a customer, you do need to be aware of privacy and personally identifiable information. So it's a really good idea to think about that up front and just think about how you're going to make use of that data and how you need to communicate that to make it clear to the users. And if you think about it, any call center does the same thing, right? They have some kind of human process in the back end where they're reviewing calls for training purposes. And as we're moving into this kind of more automated environment, the same problems exist. So we just need to be mindful of them.
Yeah, no, love mentioning that with any of these APIs are there to obviously support you and help you to build machine learning or AI into your solutions easier. However, yes, you've got to understand exactly what it's doing. Doing some testing first on some sample data is probably key to understand exactly how it's going to react. And as you said, being very transparent with people up front as to exactly, is this a human? Is this an AI? How are we dealing with your data? It's such a good point, James. Nice one. We did have another question just there on the screen about so this is kind of getting into conversational AI a little bit, but we'll go there because you're obviously a bit of an expert in that space as well. So can a bot be integrated with Lewis and Logic apps?
It's certainly in the case of Lewis, yes, it can. And Logic apps just exposes an HTTP endpoint that you can call into. The only thing you do need to be mindful of with Logic apps is latency. So you probably wouldn't want to sort of have an in-process, sending a message and waiting for a response. So as long as it's async, maybe you need to come back and proactively notify the user that something's finished. You can do that, but yes, certainly you can do. You just need to be aware of that sort of latency on the Logic app side.
Yeah, and that kind of leads me a little bit to that architecture piece as well. All of these solutions are not just one service, so please do remember that out there. Do a lot of testing where you're connecting all these different services together. So whether the chatbot is the front end, it connects off to cognitive services, but there's a Logic app behind it that's processing data and sending it to a database. AI builds into solutions as well as architectures. It's not a standalone piece, right?
Yes.
Fantastic. James, can you believe it? We're already up on time. We only touched on a few questions there, but
well, thank you for having me.
Of course. And as I said, we'll bring you back at the end and we'll chat to you a little bit more if we have other lingering questions as well.
Great. Thanks, everyone.
All right. Thanks, James. Perfect. So, oh my goodness, we are two sessions in. So we've covered computer vision and we've covered text and audio. Thank you so much for all these questions. I hope the answers are becoming incredibly useful, and I'm sure our moderators are actively answering all your questions as well. So without further ado, next up, we are going to cover making sense of your unstructured data with AI. You've already met the person who's in this video because it's actually myself. So this was when we pre-recorded some video all around Azure Cognitive Search. It's quite a fast-paced one, so prepare yourself, but we'll be back to speak to some experts shortly. So let's roll the video. Hi everyone, welcome to this session, Making Sense of Unstructured Data with AI. My name's Amy Boyd, I'm a cloud advocate at Microsoft, and in this session I want to talk through a scenario where we take unstructured data, apply AI and search services from the Azure cloud to solve a business problem. Tailwind Traders are a fictitious retail company who sell DIY do-it-yourself products. They're looking at their stores across the world and wanting to get them up to date using electronic invoices, but they also need to approach the current or historical PDF approach for invoices. Here are some examples of what the current invoice system and documents look like. One store has these in folders dating back to 2008 and around 140,000 files. If we times that by how many stores we need to approach, it's going to be a lot of files. Each one of these files has a great set of product and payment data in them that Tailwind Traders wants to extract in order to analyze current, historical, and future trends, as well as the need to locate this data for data trust purposes. The Tailwind Traders lead has heard about Search as a Service in Azure, called Azure Cognitive Search. It's a set of developer APIs and tools that allow you to build a search service on top of private, heterogeneous content in the form from web, mobile, and enterprise applications. So how does Azure Cognitive Search work, and how can it help Tailwind Traders extract data from PDF files? First, you take a data source, in our case, an Azure Blob container with PDFs in it. Cognitive Search cracks these documents open, explores them, and extracts data into an index. You can add skill sets such as Azure Cognitive Services APIs in order to recognize items in an image, extract sentiment from text, or analyze a form with Forms Recognizer. The skill set also lets you add your own custom skills, your own custom logic to extracting and analyzing data in your unstructured documents. Once your skill sets are applied, you then have an enriched index with both content as well as applied skills output that you can now search over. In the case of Tailwind Traders, we want to extract key value pairs from our PDF forms and store this data in a structured format that we can analyze and explore. We can do this by creating an architecture like this in Azure. So first things first, we've uploaded our PDF data into an Azure Blob storage account. We then connect this to Azure Cognitive Search to create an index, a data store, and an indexer. Next, we add a custom skill set that calls an Azure function. This function does some kind of custom logic processing, and in our case, it's going to take the PDF, send it to an Azure Cognitive Service called Forms Recognizer that's going to extract key value pairs from our form and send it back as output extra metadata to our Cognitive Search service. Once we have our enriched documents, we can actually store them in something called a knowledge store with Azure Cognitive Search. And from there, we can then have any kind of front-end application. So whether that's a web application with a search service, or whether we're actually outputting that data and analyzing it in a business intelligence tool such as PowerBI. So let's go and take a look at what this looks like. Okay, so the first thing we need to do is take a look at what our forms look like. So I'm here in the Azure Storage Explorer. I have some blob storage here with a container called train. So these are the files I'm going to hopefully train a model with. But let's take a quick look at one of these files first. So this is an example of a file. You can see all the different assets that we might want to extract from this file in order to store it into a structured format. So where do we go first? Well, first things first, we actually want to train a forms recognizer cognitive service. So I've created a forms recognizer service here, AI ML30 forms. It gives me some useful information such as the API endpoint I need to call, as well as keys. So how do I start training my invoice reader model to understand what's going on my invoice? Well, one of the things you can do is use curl or just REST requests to actually train and analyze and get results of your different forms. So let's walk through what you need here. I'm inside Visual Studio Code and I have some curl statements that I'm going to run in the terminal. First thing I need to do is I actually need to train the model on some example data. So I call off to our API, and then call into the custom models part of the API. I'm providing it application/JSON content. I've provided it also my subscription key, which I can get from the Azure portal. And then finally, I just now need to add the source of my data. So I'm going to go to our Azure Storage Explorer. I'm going to click on the train container and get my shared access signature. I'm going to click create and it will provide me a URI that I can use to actually call off to this API. So if I take this full command and I paste it in, we can see that that was 201. It's come back and said it was created. It provides a URL, as you'll notice, in the form of the actual API. And then this now has become my model ID. So I'm just going to quickly copy that because in order to retrieve some of the results of training, I'm going to get that by calling another command. So here I've got my Cognitive Services API, but then I'm going to put in my model ID. And you'll notice it's got the same content type and the same subscription key. I can then have a look at the actual results. So best thing I always like to do here is you can obviously just read it off the chart, but one thing I'm going to do is I'm just going to post it into this document and use Alt-Shift-F to actually format this output. So we can see the model ID, see when it was created, but we can also see the results. So we can see the documents that it trained and what its status was and if there was any errors. And we can see there are no errors in our training at the moment. So now we've trained our model. There is a model in Azure that is now trained on looking at our PDFs to extract information. So what we're going to do is we're going to choose a new form to analyze. So here I call off to our API. I'm going to put in my model ID. I've got content.json, I've got my subscription key, and again, this time, instead of using the training documents that we've already trained it on, I'm going to go to a test container. I'm going to choose one single document and get the URI for it. And then I'm going to select this full command and run it. Here we can see it was a 202 accepted, which means it's gone off and it's going to go and analyze our form. In order to get results of this, I have the same thing here. So what I'm going to do is I'm going to get my model ID. Then I also need the result ID, and that actually came out of here. So we can see models with the model ID and then analyze results. I'm going to take this ID on the end for the results and post it in here. And then we can see we've just got the subscription key on the end so that it knows that I have access. Then we get a huge JSON element. So again, what I'm going to do is I'm just going to take this content and format it. And what we can see now is a huge JSON document, but it's actually then able to get key value pairs. So you can see it's extracted the name, and the name was Brian. It's extracted the address, and it starts with 1145. And so it's telling me exactly where all these items are on the page. So now we have a model that understands our form. We actually need to build it into a skill to use in Azure Cognitive Search. So we trained our forms recognizer model, but now we need to build it into an Azure function that can be called from Azure Cognitive Search. And so I have my Azure function here. This is available on the Azure Cognitive Search Power Skills GitHub, and it gives you all the information you need to actually extract fields from using Forms Recognizer and then bring them back in a JSON format. The things I needed to edit, if I go into the local settings, I've added things like my endpoint, my API key, and my model ID, so that it's able to extract these, and I can also update these easily. And I've also edited the field mappings to meet my PDF. So we're taking things like name and address, we're taking things like invoice number, order date, as well as all the numeric values that were paid. To run this, I can go run and start debugging. This will provide me with a local host URI that I can actually call in order to test my model locally. So if I go over to something like Postman, I can call off to the same HTTP request with my format. So what I need to do is go and get one of our test files again. So let's take the next one. Get a shared access signature and copy it. Then what I'm going to do is in URL, I'm going to paste the full thing, but I'm going to take out the SAS token and put that into my form SAS token field. Click send. And we can see what comes back is I have a record and it's extracted all those fields from the invoice for me. If we go to functions, we can also see that it was executing, it printed out a request to say it was running, and then it gave me a succeeded message. I can then quit this by doing Control-C, and I'm ready to publish this to Azure. In order to publish this to Azure, you can also do this from Visual Studio Code. So we have all of our Explorer and all of our different code files here. If I go to the Azure tab, I can see that under my subscription here, I have a function. In order to deploy to a function, you can use this deploy to function app icon from your local machine. It will then go ahead and ask you for some details like a unique name as well as a location. And it will take all of the environment information from the code. Once it's deployed, just to note, under application settings, you'll notice all of my different forms recognizer options here. If you right click on application settings, you can actually upload from that local settings file. So make sure you do this before heading over to Azure. If I go into Azure, I can see it's created me a resource group and my functions app is available here. So if I click into my functions app, I can see some information about it. But I can also test it. So if I go to code and test, I can go test run. I see a post, a master key. I provide it a value in the body of the format and click run. It says it's now executed and analysed my form, and I can see that the name and the details are available to me. So my Azure Function app is now hosted in the cloud and is accessible and running the same code as locally. Okay, so we have a working Azure function that is going to call our Forms Recognizer service. And now what we want to do is integrate it into our search service so that it can run through thousands of documents. So what you'll notice down here is we've got three of the things that we mentioned. So we've got something called data sources, something called skill sets, something called indexes, and something called indexers. So let me walk through how we can integrate this custom skill. First things first, I'll go to our Postman tool. And I have a definition here called add skill definition. And in here, basically what we're going to try and do is we're going to call the search service. We're going to send it a skill set called Forms Recognizer skill. And in the body of that, we're going to tell it the name of this skill, that it's a custom web API skill, the URI, so our Azure function that it needs to call, and the post request, as well as what are the inputs. So we asked for that form URL and the SAS token like we tested. And then also the outputs, so all of our different fields that are in our skill set that will be coming back to Azure Cognitive Search. So if I click send, we can see it was a 201 and it brings back what my skill was, but the best way to check it is to go to the portal, click on skill sets, refresh the page, and now we can see our Forms Recognizer skill, and it has one skill that it runs our Forms Recognizer on. Next up, we're going to create an index. So an index is now, I want to tell Azure Cognitive Search exactly what it should be expecting. So we've got the basic ID and content and the metadata that it provided previously, but now I've added in all of my extra Forms Recognizer information that allows me to then be quite specific about, is it filterable? Is it retrievable? Maybe you don't want it to actually be retrievable or searchable, for example. And so you can provide it lots of great information in order to build your index. So let's send our index. We have a 201 created. Again, we can check in the portal. And we can see our index currently with 0 documents. So how do we get our data source, our skill set, and our index to all work together? Well, it's to create an indexer, the workhorse of the equation here. So for my index, I'm going to call the search service on indexes and pass it a name called form indexer. In my body, I'm going to tell it what is the data source, what invoice is the target, what skill set should it use, and then again my input mappings, so what it's going to have as input, and then what our document will look like when it adds in all of our different options. So if I send my indexer, we can see again it was a 201 created. I can now go to my indexes. We can see that it's in progress. We refresh it and we can see it's halfway through the documents. Finally, we can see a success message and that it's done 20 documents. In order to search, I'll go to my index. We can see it had a document count. Let's refresh that. Now we see all 20 documents are available. So if I go into invoice index, I can actually search with a star, and then what we can see here, if I zoom out a little, is all of our extra metadata. So previously we had all of the content, but it's kind of in an interesting format. Now we know where it's coming from, and we can also extract all of our different items. I can also search more complex strings. And so now we're saying, okay, filter where the country is equal to Australia. And so we can see we've got one Australian and then another one. So in this session, we built an architecture with Azure Cognitive Search at the center of it. We took our PDF files from an Azure Blob storage, we cracked them open using Azure Cognitive Search, and we applied an extra custom skill by analysing our forms with the Forms Recognizer cognitive service. This then gave us some enriched documents as an index that we can now use a search index to search over. You can also add knowledge stores which have projections of your data and index in them, and then from there you can obviously use that in any front-end application. You could use it for analytics purposes or even machine learning purposes as well. Thanks so much for joining us. Okay, we are back, and oh my goodness, so much to talk about in that session. What did we say before? We said AI solutions are all about building architectures, and we absolutely did just then. We use Azure Forms Recognizer, which is a cognitive services API. We use storage. We use Azure Functions as a serverless offering in Azure, which is a really, really neat piece. And by no means an amazing developer. I'm more on the data side. However, Functions was a good experience. And then finally, cognitive search that brought it all together. Speaking of which, speaking of bringing it all together, I would like to introduce Kakila and Adelina to our expert sessions. Hi, Kakila. Hi, Adelina. How are you doing?
Hey, good. How are you?
Hi, Amy.
Hi. Oh, it's so great to have you both. Thank you for joining us, specifically to Kakila, because Kakila, you are not in Europe, and therefore it is early doors. And we also saw you. I know. We saw you on our tech check as well, so I can only thank you for your time here.
No worries.
Okay, so we definitely want to talk first, just very, very briefly. Kakila, can you tell us a little bit about yourself and what you do?
Yeah, sure. So I have been with BP for almost 13 years now. I am a lead architect at BP and worked on various different domains in BP. Most of my time has been in the well space. Recently, I have become the knowledge management lead architect. So working mostly in that area.
Fabulous. And Adelina, can you tell us a little bit about what you do? You work with me at Microsoft.
Yes, and good segue to saying that we've also started from the same university. And my road has been a bit more mixed. I joined a consulting firm and then a startup, and throughout consulting and research, I've had various roles in UX design, then project management, then architecture, then data science. And now I'm in cloud architecture, where I feel like I'm actually combining all of those. Even though UX may sound like it shouldn't really fit in here, it actually does, because everything we do, we need to do with the user in mind. And through various industries, from financial services to retail, manufacturing, public sector, and so on. So it's more broad than deep, but still loving what I do at Microsoft and really happy to be here.
Fantastic. No, thank you so much for joining us. There is a few different questions coming in here, and I actually have a few different questions for you both as well. So let's get started. We don't have very long, but again, we will have you back for the panel at the end so we can ask you even more. One of the ones that I can just tick off the list straight away for us, I lost it a little bit there, is basically, can you get your hands on something or a similar use case to what you just saw in the video? You absolutely can. We have a short link that takes you to Microsoft Learn, and that is aka.ms/techdays-AIML30. That will take you to Microsoft Learn. And in Microsoft Learn, you can get hands-on and build out your own cognitive search infrastructure. It's actually based on Margie's Travel, another fictitious travel company we like to talk about here at Microsoft, where you can start to look at another use case, which actually brings me very, very nicely to Kakila. Kakila, can you talk a bit about, in that one, we saw we could very efficiently analyze like 140,000 different PDFs for someone, and we understood the PDF and we extracted it. Can you tell us a bit about another use case so that our users can get that in mind?
Yeah, sure. So at BP, we mostly use Azure Cognitive Services for searching of data in unstructured documents. So like you mentioned, PDFs, for example. Some of the use cases that I can think of, we actually use it to extract text from like well logs and drilling reports. We also do like image text extraction from well documents to get like recorded well measurements, for example. Those are kind of like the operational use cases within BP. From the finance side of things, we actually have like legal joint venture agreement documents where we use like Azure Cognitive Services to extract key information like names, amounts, dates, etc. And actually, since you mentioned Forms Recognizer, we actually have an in-flight project right now where we're using Azure Form Recognizer to extract key text data from our contracts, which have to be approved within 15 days. So as you can imagine, if the user had to manually go in and try to look through those contracts, we could bypass our 15 days allotment. So, Azure Cognitive Services really helps to kind of automate some of the manual process of searching through multiple documents to get the information that our users are kind of looking for.
Fantastic. No, that's such a good example to share because, I think when I've delivered this session before, that is the question that comes afterwards. It's like, okay, like if I need that exact example, like what other things can I do with it? And actually, Adelina, I'm going to come to you very quickly with an audience question that relates actually to what we just said. So can Forms Recognizer handle PDF scans of handwritten forms with OCR? Because we were looking at computerized forms.
Yes, indeed, it can. This is a function that we have as a standalone, as a cognitive service. But yes, indeed, we can also do this with Form Recognizer because let's be real. In the real life, we do have forms that are printed. Receipts that are printed, but we also have receipts handwritten or corrected. And, even thinking about early days of machine learning, detecting the handwritten text was one of the most basic exercises that we would train on, that we would learn how to do machine learning. So yes, indeed, we have this included in our services.
Fantastic. No, thank you for sharing that because I think, with OCR and all of that. In fact, in Azure Cognitive Search, OCR capabilities are built in. So we saw there a custom skill. So that's the idea that you can extend Azure Cognitive Search to pretty much do whatever you want it to do, right? And to manipulate data and put it into formats that you're looking for. But realistically, there is the option to select these cognitive services inside Cognitive Search. So definitely just wanted to drop that one in there. Another interesting one, actually, more dependent on architecture here. So either of you can probably take this one. It's from our audience. How do you look at actually doing, say, like pipelines with this kind of thing? So anything around continuous integration. I was obviously running it quite hands-on, scripting, stuff like that. When you've built it into an architecture, how does that look? How do you keep it fresh?
I guess I can take that one, and then Kokila, if you have anything to add, please do. I would say it's interesting to think about pipelines when you're developing versus when you're in production. And so when you are developing the Azure Cognitive Search service, or let's say when you're developing your search service with Azure Cognitive Search, of course, the recommendation is to use either GitHub or Azure DevOps to store your code and go through the usual stages of development. However, when it comes to production, we don't necessarily expect the code to change that much. It's not the code of the application that changes, it's the index and perhaps the indexers that will change. And so when you're thinking about CI/CD for this, it's not just about the code. You need to also think about what's my production level index and production level indexer, and where else do I test them? And one of the recommendations that we have is to, what's the right word to say this, is to perhaps stage your data before you index it, or back up your index somewhere so that, in case something happens, that's how you restore it. This is not so much about CI/CD, but if we're thinking about development and production, I guess the key message to emphasize here is to distinguish between code and indexer, because those assets need to be looked at in a similar way as you look at code.
What
Yeah,
a
and I think
fantastic answer. Keela, please add.
Yeah, no, I was just going to just add on to that and say that, at BP, we do use Azure DevOps for our CI/CD pipelines. And but like Adelina mentioned, the code doesn't really change much. It's more about the index. And, we basically build the architecture to have multiple replicas to accommodate for something like that. Yeah.
Perfect. I'm so sorry. We have to wrap up already. However, again, we will have you back at the end. I have another question queued up, Keela, specifically for you. So prepare yourself. But thank you so much for joining us. Thank you for answering our audience's questions. Okay, we have our fourth session up. My hair's starting to look a little bit disheveled at this point, but we're doing a great job. So next up is conversational AI, which I'm really, really excited about this session. So improving customer engagement and productivity with conversational AI. You'll see myself again. However, we are going to be joined by Gary after this, who has worked on me with this session. So let's roll the video. Hi everyone, my name's Amy Boyd. I'm a cloud advocate at Microsoft, and I want to welcome you to this session, Improve Customer Engagement and Productivity with Conversational AI. Okay, so let's start with a scenario. Meet Tailwind Traders, a fictitious retail company in the DIY space who have a global team of employees. Recently, they asked their employees to take part in an annual survey where they wanted to find out more about what employees thought it was like to work at Tailwind Traders. They got some good feedback about career progression. However, it was unfortunate that some of the processes employees felt were not making their jobs simple at all, such as booking vacation or accessing benefits. They want to reduce the friction of reviewing and booking vacation for their employees. The technical lead at Tailwind Traders has heard about conversational AI and believes it can help with their issue. So what is conversational AI? Conversational AI uses artificial intelligence and machine learning to facilitate more natural communication between humans and computers, commonly through speech and text. So this definition basically means we've been communicating with computers for a while, but we've had to use specific language and syntax in order to be able to do this. Now we want to be able to have a much more natural conversation with computers so that everyone has access to this technology. Tailwind Traders are going to investigate the Microsoft Conversational AI platform, which provides you with all the services and tools you need to design and build sophisticated, natural and engaging conversations. Meeting your customers' employees where they are and allowing them to use the medium of their choice, so on a variety of channels such as Microsoft Teams, WhatsApp, embed them into your website, or even an Alexa skill. Underpinning everything is the Bot Framework SDK, allowing for your bot development in C#, Node, Python and Java. Built on top of this SDK, you can use two different things: Power Virtual Agents, a no-code solution for rapidly building a bot with amazing integration into the rest of the Power Platform. Alternatively, and the focus of today's presentation, is the Microsoft Bot Framework Composer, an integrated development tool available for Windows, Mac and Linux, which can be used by developers and multidisciplinary teams to build conversational applications. So let's take a look at how Tailwind Traders are building their HR bot. Here I am in the Bot Framework Composer tool, and I've created a new project, Tailwind Traders HR bot-start. On the left, you have a list of triggers. Triggers are used to respond to external events, such as someone joining the conversation or a message being received. For each trigger, you can actually add actions to your canvas to control what happens when a trigger fires. I get a built-in greeting trigger, which actions already set up for me to send the user a welcome message. I can add more triggers by clicking on Add a New Trigger. I'm going to choose Intent Recognized. Using this trigger, I can specify example phrases, including entities. A user might say to trigger an intent, and Composer will automatically create a Lewis model for me. Once I've created my trigger, I can update any of the trigger phrases in the properties on the right. Now that I have my trigger set up, I can start to add actions to my canvas. To control what happens when it fires, clicking the plus icon shows me the actions available. I'm going to add a basic text prompt to ask the user an open question. Once my prompt is added to the canvas with the bot asks action selected, I can use the property editor to specify what the text for the prompt should be. Here I use LG or language generation syntax to create multiple variants, and the bot will pick one at random each time the prompt is used, making the conversation feel more natural. Now I can switch to the user input tab in Composer and tell it that I want to store the user's answer in a variable for me to use later. To do that, I use the property input and I can type dialog.reason. I can then add another action to my canvas, this time send a response. Here I can use LG again to determine what the response will say, and I can use my reason variable by typing thank you said dialog.reason, using the dollar notation to refer to my reason variable. Now I have a trigger to respond to someone joining the conversation and another to respond to someone asking to book vacation, but I want to handle a situation where someone says something the bot can't handle. For this, I can add a trigger for unknown intent. This lets me send a response to the user to say that I don't know how to handle their request. One more concept to introduce here is the idea of a dialogue. A dialogue gives you the ability to group actions within inside your conversation. As an example, I could take the actions I created for my book holiday trigger and group them into a dialogue called book holiday. This means my trigger is now calling my new dialogue, but I can also have this dialogue executed from elsewhere in my bot, making that logic reusable. Once I'm ready, I can click the Start Bot to test my bot. The first time I do this, I need to provide a Lewis authoring key, which I can get from the Azure portal where I create my Azure resource. Once I provide this, Composer will create and publish my Lewis application and start my bot locally for testing, which can test using the Bot Framework emulator. In the emulator, I see my welcome message because the greeting trigger was fired when I started the conversation. I can then type I want to book a holiday. This will fire the intent recognized trigger I added earlier, which in turn calls the book holiday dialog, asking me a question and repeating my answer back to me. So I am back in my bot project inside of Composer. In this demo, I want to show you how we can increase the sophistication of our bot using different types of prompts and making the conversation with our users even more natural using Lewis, the language understanding cognitive service, which, as we have seen, is deeply integrated into Composer. Since the first demo, we have expanded on our bot. We have added additional intent recognized triggers, which fire when the user asks how many days of vacation they have left, or if they ask for help. If I select the help trigger, you can see trigger phrases I have provided and the simple action to send a helpful message back to the user, as well as also some suggested actions if you really wanted to go that step further. Also, now that I have started to add more intent triggers to my bot, I can add a condition against each of them to ensure that they only fire if the result from Language Understanding Service has a high confidence score that the correct intent has been matched. This can be useful if you have phrases across different triggers that are similar to each other. Jumping into our book vacation dialog, you can see that I have added more actions to ask the user about their vacation request. Here, I have used 8 time prompts to ask the users for the dates of their vacation, a multi-choice prompt for the type of vacation they're going to take, as well as using the basic text prompt that we saw earlier to accept the user's comments about the request. Switching to the emulator for a minute, you can see a conversation I've had with the bot showing this dialogue. A couple of things to note here. Firstly, because the Lewis service analyzes every message from the user, I don't have to provide responses to the date time prompts in a specific format. Instead, I can say something more natural like this Friday, and Lewis will use its powerful pre-built entity support to recognize and return the correct date to me. Also, where I've used the multi-choice prompt, Composer automatically adds these to the outgoing message as suggested actions, allowing a user to quickly select their choice as an alternative to typing. At the end of the dialogue, I use a confirmation prompt to ask the user if all the details are correct. But what if the user has made a mistake and answers no to, say, this comment question? We could then ask some structured questions to find out which value they wanted to change, or simply restart the dialogue completely. But it's not very natural though. Here, it'd be much more useful if a user can just interrupt the flow and say something like, change my comment to well-deserved rest. To enable this, we need to do two things in Composer. First, I've set the allow interruptions property to true on the confirmation prompt. This means that if the user doesn't answer yes or no, the Composer will check to see if my user's reply matches another trigger in my bot. If it does, then the trigger's actions can temporarily take over the conversation. I have also added a trigger to handle the interruption. Here I created a nested trigger on the book vacation dialogue, since this trigger only makes sense within that context. Here the trigger phrases are things like change the comment, but I have also used machine learned entity support, which allows Lewis to recognize and extract my new comment as an entity if it is provided. I can do this by providing the name of the entity and an example of its value, such as comment equals long weekend in the example phrases. Then I tell Lewis to explicitly look for the machine learning entity by adding @ML comment underneath my phrases. There are also many more types of pre-built and custom entities that Lewis can help you recognize and extract. Then I have added actions on my canvas to handle the conversation when the user triggers this interruption. I have used a basic text prompt, which we will ask the user for their new comment, but we'll skip this step if Lewis recognised my comment entity. And I do this using the notation, which maps to recognise entities, and setting the value property of the prompt to @comment, which we pre-fill the prompt, meaning we don't need to ask the user the question. I've also told the prompt to save the new comment into the existing dialog.comment variable. Once the interruption trigger actions have finished, the previous flow will resume and the user will be prompted to confirm the details again. But this time, the comment has been updated with my new value. I can answer yes and I receive a confirmation message. So far, we have added triggers to handle greeting the customer and also to respond to vacation booking requests using natural language. Now we want to expand our bot to include the ability to answer frequently asked questions taken from the Tailwind Traders FAQ page. To do this, we can use the Q&A Maker cognitive service, which can extract questions and answer pairs from web pages or documents into a knowledge base and then return the most appropriate answer based on the user's question, even if they phrase that question differently to the way that it's worded on the FAQ page. To add Q&A capability to our bot, we add a new knowledge base to the bot, and here I provide the URL to the Tailwind Traders FAQ page. I could also point to a PDF, Word document, or even start from scratch and add the questions and answers manually myself if I wanted. Composer will use the Q&A Maker service to create my knowledge base for me, and once it has been created, I can edit the question answer pairs directly in Composer. I can add alternative phrases, which are additional examples of how a user might ask a question, helping to increase the accuracy of the answers that are returned. You can manage your knowledge bases at any time by choosing the Q&A option in the menu on the left-hand side. If we go back to our design page, we can see that a new trigger has been added, which is fired when an incoming message from a user matches to an answer in our knowledge base. Composer has automatically added actions to my canvas for me to handle sending a response containing the answer back to the user. There is also additional logic to handle more advanced Q&A Maker functionality, such as multi-turn answers, which we aren't using here. Now we are ready to test our new Q&A capabilities. Since we were already testing our bot earlier, we can click Restart Bot. Because we have added a knowledge base to our bot, we now need to provide a Q&A Maker subscription key, which you can get by creating a Q&A Maker resource in the Azure portal. Composer will then create our knowledge base in the Q&A Maker service and start our bot for testing in the Bot Framework emulator. I still see the welcome message shown when the greeting trigger fired. I can also still ask, how many vacation days do I have? Which will fire my natural language intent recognized trigger. Now though, I can also ask a question such as, what happens if my manager changes? And I see that an answer from my knowledge base is found and sent back to me. You can see that in just a few simple steps, I have added a really useful ability to my bot, and keeping my bot relevant and up to date is as easy as making sure my questions and answers are up to date in my knowledge base. Now that our Tailwind Traders bot has the ability to help me book vacation and to answer frequently asked questions, I'm ready to publish my bot to Azure. To do this, I can head over to the Publish page within Composer and create a new Publish profile. Here I can choose between deploying to an Azure web app or an Azure function. There is a great document in the Composer documentation over at docs.microsoft.com, which will walk you through the steps you need to provision your resources in Azure and how to create your Publish profile. In the interest of time, I have already created my Publish profile in Composer. So to publish, I just select the profile and click the Publish to Selected Profile. Publishing to my environment will then start, and Composer will update the status here once it has completed. So our deployment has completed successfully, and if we go over to the Azure portal, I can see the resources I've provisioned when following the documentation to create my Publish profile. Let's take a look at the Azure Bot Service channel registration resource. From here, I can test my bot in web chat, allowing me to test that my deployed bot is working correctly and also demonstrating what my bot might look like if I embed the open source web chat control into my own website. We can now use the bot just as we did when testing in the emulator, so I can see my welcome message, and if I type help, I can see the help message provided back to me. Once I've confirmed that my deployment bot is working correctly, I can move to the Channels tab. Here I can surface my bot through many different channels available via Azure Bot Service. You can see the web chat channel is enabled by default, but that we can also enable channels such as Microsoft Teams, Facebook Messenger, or even via an Amazon Alexa skill. Clicking the Teams icon takes me to the configuration page for the channel, where I can find steps and instructions to publish to this channel and even enable my bot for Teams calling capabilities. Clicking Save enables this channel for me, and I can then test the bot inside of Microsoft Teams by clicking on the Teams link. Once inside Teams, I can chat with my bot just like employees of Tailwind Traders will, asking to book vacation and providing the details to the bot. So now this bot is available to all internal Tailwind Traders employees via Microsoft Teams. Tailwind Traders took another survey and found improvements in their processes that are in place. This is keeping their employees happy and healthy. Thanks so much for joining us, and we're excited to answer your questions. Fantastic. So if you want to start getting hands-on with the bot framework Composer, do go to that link at the bottom of the screen now, so aka.ms/techdays-AIML40. You can also go to aka.ms/trycomposer, which is the tooling that we were using. In fact, I won't talk about this. We'll bring on the expert. So let's welcome Gary Pretty, who is a senior program manager in the conversational AI team at Microsoft. Hey, Gary, how are you doing?
I'm doing well, thanks, Amy. How are you doing?
Oh, not too bad, not too bad. We've had a lot going on and we've had a lot of questions. Yep. So are you ready? Because I feel like anyone from anyone from a product team, they get a lot of questions, right? So
no pressure.
Absolutely. So Gary, tell us a bit about yourself and what you're working on at the moment.
Yeah, sure. So I'm a senior program manager on the conversational AI team at Microsoft. So within conversational AI, we build the bot framework and the Composer, which is the visual designer for the bot framework that you've just been seeing in the session. And that's a product that I focus on from a PM perspective as well. So yeah, it's very busy at the moment. But and it sounded like you already talked about this with James earlier as well.
Yeah, Lewis definitely came up in our text and audio, and we kind of spoke about some of the use cases there, and actually that bleeds very slightly into conversational AI. And so, yeah, we've already done some cool stuff around that. So are you ready? We're going to jump into the questions. People keep sending your questions in. This is where you get them answered live on air. So one of the first ones, this isn't really the question. We have sent a link to the person who asked the question, but I think it's a good point to make about the two kind of different platforms. Can you tell us a little bit about Power Virtual Agents and Composer and how these things interact with the bot framework?
Absolutely. You won't be surprised to hear this is not the first time I've had this question, but every time I get asked it, it gets easier to answer, which is awesome. So Power Virtual Agents is part of the Power Platform. It is built on top of the Bot Framework SDK, just like the Composer is. So they're both underpinned by the SDK. PVA, Power Virtual Agents, is aimed primarily at business users and citizen developers. It's a no-code environment. It's really super simple to actually get up and running, and it's got awesome integrations with the rest of the Power Platform, Power Automate, and Flow, etc. Right? Composer is primarily aimed at the developer audience, so multidisciplinary teams, yes, but primarily developers. Now, previously we used to get asked, where do I start? Well, really, the answer is wherever it makes most sense for you, and whichever tool makes sense for you to actually pick up and get up and running with. The great thing about Composer and PVA today is that they now work together. Because they're both built on the SDK underneath, we can actually now start a bot inside Power Virtual Agents. There's a button in there saying Open in Bot Framework Composer, and then you can actually have developers and business users actually collaborate on the same project, and you can extend your PVA project. Even better, you can build a bot inside of Composer, and you can turn that into what we call a bot framework skill. So any bot can be a skill, and all that means is it's available to be called by another bot. So you could have a Power Virtual Agents project, which you surfaced via web chat, and maybe you've built a bot over here in Composer, which is a calendar skill and has all of sort of calendar management capabilities. And you can simply plug that functionality into Power Virtual Agents. So the two work really nicely together.
That is a great story, isn't it, with connecting them? And also, I love that idea of being able to bring both people in your organization that are building in Power Virtual Agents, as well as the amazing developers that we're speaking to right now that actually, like, myself, when I first started working with Gary, I hadn't really used the bot framework in a very long time. The last time I had used it was, say, like a couple of years before with the SDK. And Composer is a bit of a dream, actually. And one of the pieces that impressed me the most, Gary, can I ask you this question? Where is the code behind Composer?
Right. So it's a good question, because with a lot of tools, certainly designer-based tools, you often find that the code is sort of hidden away and you can't get access to it. The great thing about Composer is when you are editing your dialogues and your conversation flows inside of Composer, what's actually happening underneath is there is a real SDK project. Like if you choose the C# runtime, then there's a Visual Studio project there. You can open that up in Visual Studio, and you can make many of the same changes that you could do if you built a code first bot with the SDK. Ultimately, what Composer is doing is when you're designing your flow, it's serializing the design into JSON, which then at runtime gets loaded in and executed. But the nice thing about the fact that Composer is creating a real SDK project underneath is we can take that, we can check it into GitHub, we can run it through a normal CI/CD pipeline in exactly the same way that you would do with any other web application. So it's a really nice story. And even better, if you hit a limit in Composer where there's not an appropriate action for you to do what you want to achieve, you can just fire up Visual Studio or Visual Studio Code, and you can write your own actions, which then appear in that context menu where you can add them to your flow. And so you can really use Composer to build whatever you want. Fantastic. Great stuff. Well, now I've borrowed too much of your time. I just felt like it needed to be said. Full source code control, people, full source code control. One of the questions from the audience is about can the bots interact with Siri and Google Assistant? Because we obviously showed their Teams as a channel. I mentioned Alexa. Can you tell us a bit more about, say, Siri and Google? Yeah, so Siri, not so much. I mean, the Apple ecosystem has always been sort of fairly closed. But certainly from a Google perspective, really any platform that has an appropriate API to allow you to interact with it, then you can write what's called an adapter for the bot framework. And you can use adapters to basically join those platforms with your bot. So if you head over to the Bot Builder community project in GitHub, which I manage along with some other MVPs like James, and in there, we have a number of adapters for WhatsApp, for Google, for Twitter. And effectively, the adapter takes a request from, say, Google Assistant, and it will transform that into something that's understood by the Bot Framework SDK. And then when you send your Bot Framework message back, we transform that into the appropriate Google response. So you could go and write your own adapters, but we have a ton of pre-built adapters available today in the community. And that's github.com/botbuildercommunity.
github.com/botbuildercommunity. That was actually the next thing I was like checking in my documents. I was like, have we got that link? Have we got that link? Amazing. So a question quickly just came up. So just for clarity, if you ask a citizen developer to build basic versions in PVA, then the developer takes over and extends it for a complex use case. That was what you were saying, wasn't it?
So you can have a citizen developer build use cases within PVA using the PVA tools. But then if you wanted to add additional capabilities to that, then you can open that within Composer, or you could call another bot that the developers built as a skill. So it's not that you would necessarily have the developer rewrite all of the existing capabilities. It's a case of the developer and the citizen developer and the developer working together on parallel use cases inside of the bot.
Okay, I see. Yeah, no worries. Speaking of which, so say organizations are building lots of different bots, and obviously a lot of them might be using something like PII data. We did have a question. Should we label PII entities when we've got different data sets, but we need to extract the same entities? In a more sort of broad context, PII data, how should we handle that from a bot perspective?
Yeah, I mean, it's a common scenario, especially with, the onset of GDPR. We need to make sure that we're being incredibly careful with data that's passing through our bot and services. Luckily, there's a number of different things that we can do. I mean, firstly, Azure is incredibly compliant, and Lewis and Q&A Maker are all Azure-based, so you get all the same sort of compliance with many of those cognitive services that you do with the other Azure services that you might use. From a bot perspective, we can use something called middleware to actually intercept messages on the way into and on the way out of a bot. That means that we actually have the ability, if we want to detect PII data and strip it and remove it. So, a great example is I built a bot before I joined Microsoft where we used this middleware to actually strip out PII data. We used a combination of our own sort of regular expressions and different detection logic, and the Microsoft Content Moderator cognitive service is great for this as well. So you can use Content Moderator and similar methods to find PII, strip it out. We would strip it before we logged any telemetry. So we would actually log messages, but we would, obfuscate things like credit card numbers, etc. And then we would send it onto the bot. Now, when you're sending messages to Lewis, it's not my specialism sort of area in terms of the Lewis service itself, but I believe there is, we don't use customer data to train our own services at Microsoft. I think that's still the case. Secondly, I believe there is a flag that you can append to the Lewis URL when you are querying Lewis to basically say, do not store this utterance. Don't store this utterance for me to label and train later. So effectively, that data is never at rest. It's only being used in a sort of transitory fashion.
That's good. That's good. Thank you for sharing that, because I think, I'm sure all of us watching get very excited about new tech, and then sometimes you have to have those questions answered. So I really appreciate. And
I think one more thing is Q&A Maker. For Q&A Maker, those resources exist within your own Azure subscription, so you are as much in control of that data. It's actually using Azure Search behind the scenes, so you're in control of that data. That's just sort of one more thing to sort of add in on that point.
Amazing. Gary, can you believe we're out of time already? You did a superb job of answering our audience's questions. Keep those questions coming. Gary, you're going to join us again very shortly for our end of Q&A panel. So should there be any other thoughts around conversational AI, please do keep asking these questions of Gary. He's going to join us again shortly. So thank you very much for joining us, Gary.
Fantastic. Thanks very much.
Okay, we are on to our final session. Can you believe it? Number one. So we have covered computer vision. We've covered text and audio. We've covered knowledge mining, so Azure Cognitive Search and its various architecture components. We've then covered conversational AI as well. Now, what I want us to talk about and focus on a little bit is around that move from pure developer API, so calling an API or uploading some amounts of data into a UI, to start thinking a little bit more about these data science approaches. So without further ado, I'd like us to talk a little bit about starting to build machine learning models faster than you think by one of our amazing cloud advocates, Cassie Brevu. So let's roll the video.
Hi, and welcome to Start Building Machine Learning Models Faster Than You Think. I'm Cassie Brevu, and I'm a cloud developer advocate at Microsoft. Today we're going to be talking about one of my favorite tools, the Azure Machine Learning Designer. It's a no-code way to do drag and drop style functionality to build a machine learning model without writing any code, although you can write code if you want to. So here's our agenda for today. The first thing, we're going to start with the basics, make sure everybody understands what machine learning is, how it relates to programming, traditional programming, and then also the model building process. And then from there, we're going to build out a full model with the Azure Machine Learning Designer. We are going to start with the basics of what is machine learning. And really, when you start thinking about machine learning, you probably think about artificial intelligence, and you've probably heard AI. Maybe you don't know much about what it is or how it actually is used, right? And so really, when people talk about AI and ML, they're simply trying to mimic human intelligence with a computer. And there's different ways that we can do that. And the one we're going to be talking about today is machine learning. And so really, machine learning is just taking different techniques to improve on a specific task. And we're doing that with data or experience. So just as we go through life and collect data or experience, we use those to make decisions later. We're going to provide our machine learning model with data so it can learn from the patterns that exist and create a machine learning model. And then within machine learning, we have deep learning. And deep learning is just a subset of machine learning. And these are our neural networks. And really the only difference is the amount of layers in a neural network. And if that doesn't mean anything to you, don't worry about it. I like to think about cake and how many layers there are in cake. The more layers, the deeper the neural network. So when we're talking about deep learning, we're really talking about machine learning in a neural network with multiple layers. And it can be as little as 3 to as many as the data scientist adds to their training. And I think for people that are new to machine learning, but had that developer background, it's kind of cool and helpful to think about the different ways that traditional programming and machine learning are actually very similar. So with traditional programming, we have the data that's coming in, right? That's the user input. We are writing this function, we are statically writing the logic, and then a computation happens and there's an output, right? So a human is statically writing the algorithm that the data is going through. Now with machine learning, we still have our data input, which are now called our features, and then our output is moved up to the top, which is our labels. And so we have our features and our labels, and these are now both our input, and we want to get out an algorithm or a machine learning model. So things get moved around a little bit. There's definitely differences, but when you think about it, you can think of traditional programming, a human is statically writing code, and with machine learning, it's dynamically created with data. So it's like a function that's created with data and exploits the existing patterns. Just like in traditional development, we have the software development lifecycle. There's kind of a life cycle for machine learning models as well. And this we're calling the model building process. And within this, there's these different steps that you go through. So when you start to think about building a machine learning model, the first thing you need to think is, do I have data to build this model? So you need to find, select, or create that data, and then you need to process it so it can be put through an algorithm. And then from there, we're going to create a model. We're going to select a learning algorithm, and then we're going to train that model with the data. We're going to test that model on unseen data, select something that's good enough, and then deploy that to an API to be used in our application, right? So these are kind of the steps that you go through. You need that data, you need to select an algorithm, you need to train it, you need to test it, and then deploy it. So the use case for the model that we're going to be talking about today is Tailwind Traders. So Tailwind Traders is a retail store, and they're having issues with their logistics. They have too many items at one store and empty shelves at another, and they think that they could use machine learning to better forecast the amount of items that are needed at each store so that they can have full shelves at all of their store. So the problem that we're going to solve today then is, what are the forecasted sales quantities per item per store for the next 4 weeks? This is called a time series forecasting regression model. And if you didn't remember any of that, don't worry, because we will talk about it more. So another thing when you're starting to build these models and you have this problem that you want to solve and you're not really sure what to do, we have this awesome algorithm cheat sheet. And from here, you can take a look and start thinking about, what are you trying to do? So we are trying to predict values, right? Because we're trying to predict the amount of sales per week, per store, per item, so we can better forecast the demand needed. So here you can see the Azure Machine Learning Studio. This has all kinds of amazing tools within it. We're gonna focus on the designer. And in order to get the Azure Machine Learning Studio, it's just a resource that you create in Azure, and then you can go directly to it at mls.azure.com once you've created that resource. So for here, if we click on the designer, we can actually look at some of the samples they have available. So this is really nice when you're getting started. You can grab a pre-built model right in here and then start playing with it, pulling apart and kind of reverse engineering what happens. But what we want to do is actually create a new model. So we're going to click the new button here. And I've already uploaded some data sets for this particular model, so I can grab it from my data sets here. Now, there's other ways to get data into the workspace that aren't just uploaded via the data sets assets in Azure Machine Learning. There are data input and output modules. So if you look here on the left, we have all these different modules that we can use to start building out our model. And if we wanted to, let's say, import data, so we didn't have to import our data each time we went to build the model, we can go to a data store. And if we look at the different types of data stores, we can import from all types of data sources, which is great. So many ways to get that data into the workspace. We are going to work with one that static CSV that we just uploaded for this. So now that we have our data in our workspace, let's take a quick peek at our data. I can click on the module itself, and the properties over on the right then show up, and I can click Visualize. And this will pull up a visualization for me to then see what columns I have, how their different statistical distributions are, so that I can better make decisions on how to train my model. So here we can have ID1 and ID2 being the ID of the store and then the ID of the item. We have the date timestamp for each week. We have the value, and now this value has already been transformed or normalized, where we've actually taken it from its value of anywhere from 100 to 200 items, and we've done a log transform to simplify that number without removing the statistical importance and difference between the items in it. We've also added RDPI, which is an economic index, and then we've extracted the different time features that we need in order to build our model. So you can see some of these are like year, month, week of month. If there's a holiday, that would be an important thing to understand how that's going to affect sales. Then we have some of our Fourier transforms here, which I'm not going to get into much, but definitely read more about. It essentially gives us a different way to graph the patterns of the sales to time. And then we also have our lag. So our lag days are what's happened in the previous 26 weeks, and add that to my current row, which is something called autocorrelation. So now we have a better idea of what some of this data is looking like. And here's some better examples of that autocorrelation here. I can click on the value, and then from here, I can actually see different information as well as get visualizations of the distribution of that data. So this is a really nice way to get kind of a high-level visualization of the data and what's happening within my data right after I import it. So that's awesome. We got some better insight into what our data looks like and what we're going to be using to build this model. The next thing I want to do is select columns in the data set. And so I can actually just search and drag and drop my module, and then I can connect them just like that. And when I connect them, I can then go into my properties, edit the columns, and say by name. And what we're actually going to remove is the time column, because we've actually extracted all the values of the time idea, essentially, or the concept. So we're going to use some data to train and some data to test. And so I'm going to connect my data set to my split data. And I'm just going to go ahead and say, let's do a 70-30 split, 70% to train, 30% to test. You can see that I've already created a compute target, which you'll want to do here in order to run the model. And it's automatically selected my default compute target, so I don't have to actually change that. Now, the next thing we have here is we have all these awesome machine learning algorithms built in that we can grab. So I'm going to actually grab the boosted decision tree. But let's also take a look at some of the other ones we have. We have different types of regression. We have clustering. We have classification. We also have some recommendation, computer vision, and anomaly detection. So there's a lot you can do with the modules right in the designer. So now I want to train the model. So I'm going to grab that. And then I also want to score the model. So I'm going to grab the score, I'm going to grab evaluate, and drag all these onto my canvas. So I'm going to go ahead and connect my algorithm to my trained model. I'm then going to connect my test data. I'm going to connect my trained model here, and it's going to score, so it's going to use that model and it's going to check to see how it performs, and then I'm going to drag that to my evaluate. You'll see it's telling us here that we need to update our model, and that's because it needs to know what it's trying to predict. What we're actually trying to predict is the value, which is our number of items. Now we can go ahead and hit submit. We're going to click create new, and we're going to give it a name, and then we're going to click submit. And now this is going to train our model for us. While this runs, I'm actually going to flip over to another model that I've already created, and I'm going to show you some other things that I added. So once it's done running, you'll see something like this. And if I click on the module, again, I can go into the properties and I can view the data visualizations of how that model performed. So I can see the value, and then I can see the scored label, which is what it predicted. I can also go into evaluate model and get some more metrics here. These are the error rates, and we obviously want those to be very low. And then this we can kind of think of as our accuracy. But if you're new to machine learning and you didn't know what to do, you can actually go into the model evaluation, click on the help document, and this will bring you to our documentation. Once I have ran and deployed this model, I can actually go over to the endpoints here, and this is where I can see the deployed endpoint that we would have created for the model in the designer. I can test it right here. I can also consume it right through this endpoint. So here's my Jupyter notebook where I'm going to do some of my pre-processing of my data and then post those future dates to the API we just created to see what that result is. So with Jupyter notebooks, it's a fantastic tool that a lot of data scientists use to build models. I'm going to go ahead and just shift enter, which runs each cell. I can get a printout of the data frame for my forecasting data to get kind of a quick view of what's happening. I'm going to filter by the store ID and the item ID that I want to get a prediction for. I'm going to then add the future 4 weeks that I'm going to post to my API to get a prediction. I'm going to add in the different days between the week timestamps so that I can check for holidays. And then here, I'm going to grab the last 26 weeks and add them to the current row to get that auto correlation. So I have that leg data. I'm then going to create my time features by extracting that from the time column. This is my logic to create the holidays. And then I'm going to create the for your features. So I know this is a lot very quickly, but don't worry about it so much. This is all specific to a time series regression model. So I'm going to keep shift entering through. Here is where the important part is for you, for the models that you build. This is my method that I'm creating to get the prediction. And I'm creating the JSON that I'm going to then post to the API. I've already added my URL API key. So I can just go ahead and run that. And then here I'm going to post each one and print out the prediction for the next 4 weeks. So I can see for store ID 2, item ID 1, here's the prediction for the next 4 weeks. So I hope you learned a lot. We went through a lot of information. The Designer is a great place to start building machine learning models. I built my first model in it and went from there. Check out our amazing resources that we have on Learn to continue your learning journey at microsoft.com/learn. And again, thank you. I'm Cassie Brevu, and check out the short link for additional resources and learning modules to continue building machine learning models faster than you think.
Fantastic. So big thanks to Cassie there for taking us through a little bit more into the area of data science. She talked about forecasting. We talked about training models, deploying models, evaluating models, and using that amazing documentation that is there to support you. Now, someone, please do continue to ask your questions. Always ask your questions. Here is an updated agenda. We've had so many great questions and conversations. We've pushed it out very, very slightly. So up next, we are actually talking to Marta. Marta is the program lead for all data programs at White Hat. Hi, Marta.
Hello.
Hey, how are you doing?
Yeah, very well, thank you. Very, very well. I'm very excited to be here.
Great stuff. Can you tell us a little bit more about what White Hat does and what you do there?
Yes. So White Hat is an apprentice provider for not only data apprenticeships, but for all different apprenticeships, and basically came to kind of transform the educational space and try to an alternative to a lot of university pathways that are out there today, including data, and that's what kind of I'm doing here today. So a lot of what brought me here came out of a very similar session to what we've just had today. So I was like reflecting back to like you, Amy, in that session, and like when things were in person quite a few years back, and how inspired I felt. Like, oh my God, this is actually really cool, and kind of my journey there. So today at White Hat, I'm to kind of create that path for data or future data scientists or data analysts that, and kind of support that transition from the traditional way to get into the business.
Fantastic. Oh no, that's brilliant to hear. And yeah, as you alluded to, myself and Marta met at an Azure Machine Learning Designer session, and from there she has this amazing data science career now. And so actually Marta was the first person that came to mind of who we can explore as an expert, who can ask questions of in this sense. So first things first, can I ask you a question just more about development languages? So in this space, we saw there Cassie was using Python and Jupyter notebooks. What kind of trends are you seeing in the data science space with languages and tooling?
Yeah, so all of the questions that we're getting from either clients or apprentices at the moment, it's a lot of Python, but funny enough, I got a request today from someone trying to get to an Azure ML instead of like Jupyter notebooks and the Python that we do today, which is great. But it's very, very heavy on, Python. Everybody wants to do all things Python and quite a bit of like visualization. But it's mainly that everybody wants to start really getting their hands on once they had a bit of a play around with like other tools that are a bit like more pre-packaged tools, and they want to kind of transition into them, getting to do their own bits and pieces. Some of the, like, depending on what the actual client does, but not so heavy on R as it was back in when probably me and you were trying to like transition into the space.
I know, right? Yeah, no, it did. There is support for R in Azure Machine Learning, which is great. We have a gentleman called David Smith on our team. He's an uber expert in the R space. So there is, I think, a lot of people have said it's kind of like if you come from a statistics background and you're into an organization that deals a lot with that, they might be more inclined to R. But then you also have people coming from the developer background and they maybe feel more comfortable with something like Python. That's a kind of rumor I've heard.
Yeah, no, it's totally true. And it's also, I think, Python is a more appetite, like it's done a better job at like marketing itself out there as a more accessible language for people that don't have that research background potentially. That's how my experience from people that read about it, hear about it, and not so much on the R front.
Yeah, no, that's really interesting. We do have a couple of more technical questions. I was wondering if you could help us with them. So one of them is, can I use cross-validation to evaluate a model? So from an Azure Machine Learning side, yes, there is a cross-validation module. But Marta, can you tell us a little bit more about what cross-fold validation is for the rest of our viewers?
Oh, God, there are lots of technical questions from the team.
Straight in
there.
It's
a really interesting question. And I like to think about with the apprentices and how we like kind of try to, and bear in mind that I have to explain this to people that have never heard about machine learning models on a daily basis. So it's quite an interesting question to start with. But basically, if you think about how can you make sure that your model is not starting to develop or understanding patterns that are not necessarily patterns, but noise? And because once you start to kind of, your model can or be fitted to a really particular pattern that is has identified. So what you want to do when you go do cross-fold validation is you divide what you're going to test to make sure that you test on this little bit, then you test on this other little bit, you test on this other little bit, and then you test on this other little bit. Then are your test results consistent across all the different pieces? And Kasia mentioned about pies. Yes. So it's like testing quality on your pie. So maybe in this little bit of the pie, it didn't go so well. So maybe it's worth testing in this other little bit of the pie, just in case the whole pie is a bit of a mess. So it's like, if you think about like cross-fold validation in that way, you kind of making sure that the whole pie is very good quality pie, rather than maybe it's just you tested this bit and the rest of it is not so good.
Interesting. And actually, that leads us quite nicely onto another question, I think, that is more around overfitting. So cross-validation can help us understand whether we have a good accuracy or precision or recall across our whole data set. Can you talk to us a little bit more about overfitting and why we might want to be careful of that with machine learning?
Yeah, and this reminds me of one of the questions that people used to be like the question of like data science interviews that I remember I went to, like the paradox, the complexity paradox, and all of those conversations that are very common when you go into the data science world. So if you think about overfitting and coming back to like data examples, like if you get like a ready-made, like a fitted dress to your like size, and it's very, very, very fitted to the current weight that you are today, for example. Maybe for the weight that you're going to be or the shape that you're going to be tomorrow is not going to be of any use to you. So you're basically resolving a very, 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 very specific problem. But then when you try more general sizes, so let's say that you were designed to a dress for me and my shape only. Then if you put it on a H&M store, that dress is not going to fit most of the general population. So you're not solving the general problem. You're solving a very specific problem that is a dress for exact my body shape. So it's that trying to think, because this like the words are just so like technical, but it's actually quite simple. Like if you're trying to design something that is very, very specific to really, really tiny little thing, then when you apply it to the rest, it's not going to be of like any use to anybody.
Yeah, no, it's a really, really good point. And we talked a little bit about actually in a previous session with something we call LUIS, our language understanding service. And that has to have that ability to be more flexible based on language, because if I say vacation, do I also mean holiday? In the UK, we use that word quite a lot rather than maybe vacation and stuff like that. And the ability for it to be more flexible, and that's that kind of idea. Like if you build a model and then put it out into, you know, the real world out there, if it's trained so specifically, I remember seeing, oh my goodness, in like data science theory, like a graph with all the data points on.
Yeah.
And overfitting is like this squiggly line that goes through the data.
It's like
and
that.
Then,
when
and
everything
it's like
looks
just
a bit more like a constellation, it's definitely not a model that you can actually put anywhere into the world.
doesn't feel achievable, right? Whereas actually the one where it's got more of a sort of general curve to it is actually the one that is able to be more flexible in real life. So accuracy or precision or recall, in fact, any of your evaluation metrics always have to be considered with a wider view, not just gaming that number even higher. In some sense.
Exactly.
That's fantastic. Marta, we are going to keep you on the screen and continue discussing the amazing work that you do, but we're also going to actually bring on all our other panelists as well. So we're going to have a little party going on here. And the key thing here is please continue to answer your questions. If there was something that wasn't answered, was it conversational AI? Was it computer vision? Was it conversation? I already said that. Was it data science related? Then please do continue to share your questions. And here we have it. We have all of our amazing experts that we've seen today. So Willem over there in our top corner from our computer vision session. We've got James joining us again from text and audio. We have Adelina and Kakila joining us for knowledge mining. We have Gary at the bottom there from conversational AI, and Marta just next to me. I'll get that one day to talk more about data science. So please do keep those questions coming in. Otherwise, I'll just ask all our experts all the questions I want to know. So speaking of which, James, can I come to yourself and Willem, actually? You're both AI MVPs. Can you tell us a little bit more about what an MVP is? Willem, you go with that.
So, yeah, you get an MVP award for being active in the community. So just like James, I'm doing a lot of open source work. I actually run the Global AI community, which is a worldwide group of people that are interested in AI. I try to bring together local meetups, just talking about AI, doing workshops, that sort of stuff. And that's how I got the award. Microsoft likes these kind of initiatives and hands out these awards just to thank community members for all the hard work that they do throughout the year.
Nice one. And so don't just look for people from Microsoft, because actually there's a lot of great real world knowledge from our whole MVP community. So look up all of our great AI MVPs. And actually, Willem, if I just quickly come back to you again, talk to us more about Global AI community, because I don't know enough about it, but which is a lie. I'm heavily involved. But Willem, tell us more. What is Global AI community? How can people find you?
So people can find us on the website globalai.community. That's an easy one to remember, I think. If you're interested in learning about AI, whether you're a beginner or a more advanced a person that has done a lot of AI models in the past, we have online workshops. We have online videos on YouTube that you can watch. It's all on our website, so people can find it over there. In normal circumstances, we organize in-person events for local meetups. So organizers sign up on our website and set up a meetup for example, a Global AI bootcamp or a Global AI on tour that has more video sessions. And that way people can just go to a local meetup and have a good time there.
Brilliant. And actually, a few people on the screen have spoken at Global AI Community, including Gary from our engineering team. He's spoken on your AI Talk series. So definitely, I definitely wanted to ask you about just community in general. And so MVPs, Microsoft Value Professionals are obviously very active in communities, but I want to kind of take this time to say that we have covered so much in this session, but the key thing is I actually learn a lot of the ins and outs and all of these great questions you've been asking. I actually tend to learn them from community environments. Say it's not my specialist area and I can't just tap up Gary, at work as the PM who works on it. Actually, communities are a fantastic place for that. So just wanted to give that shout out just there. And actually, James, I wanted to come to you. You're obviously very active in the community. You touch all sorts of different spaces, text, audio, Lewis, conversational AI as well. Can I ask you, what is your approach to learning something new in the Azure AI platform?
That's a great question. So obviously, everyone's learning style is different, but for me, the best way for me to learn is to try something hands-on. So if I can follow some tutorials on Microsoft Learn, just to get kind of a feel for, how to get started with things. From that point on, you can sort of dive into the technical detail and documentation and the code if you need to really understand what's going on. But I think just from a general awareness point of view, you can't really be just, going through an hour-long tutorial, really, just to get a feel.
That's fantastic. And yeah, you're so on brand, James, for us there, because after every one of our sessions just there, we have these Tech Days Dash and then AI ML 10 for computer vision. We have AI ML 20 for speech. We have AI ML 30 for cognitive search. And then we have AI ML 40 for conversational AI, as well as AI ML 50 for starting to build machine learning models faster than you think. So yeah, do go ahead, go jump onto those Learn modules, try them out. Once you're in there, I always feel like you then start getting the, James, a bit what you said, kind of like the domain, the wording that people use in products and stuff like that. And then searching docs actually becomes incredibly easy.
I agree. And I think, you've touched on it there. The important thing is not to be intimidated by anything you've seen today, because, as much as anything, it's the words that are scary, not the application of it.
Yeah, no, it's a really, really good point. Thinking of actually intimidating, not the best way. Let's turn that one on its head. Challenging. We've covered a lot of different things, right? And a lot of the things that we covered tended to be big architectures. And so, Kakila and Adelina, I'd like to nip back to both of you and just dive a little bit more into that architecture idea. So you are both obviously architects in your retrospective places, and you've been doing stuff around knowledge mining. Kakila, for that cognitive search setup, that knowledge mining setup, when you're thinking about the use case and the user interface, how do users actually use that technology? Like where did they come in and get value from the knowledge in that data?
Yeah, sure. So, when we come up with a knowledge management solution, we definitely get the business involved to contribute towards what they want to see and what kind of user experience they want. So we have design thinking workshops, and we draw out stuff, and some users want just a box where they just enter in whatever they want to search for and then get the results back. Some users may not like the text search as much, and they want to kind of drill down into your metadata. And so we have a user experience for that as well. So it just depends on kind of what the user is. Yeah.
That's brilliant. And Adelina, you worked really closely with Kakila and team and kind of have put these knowledge mining solutions, worked obviously with BP as a customer, which is fantastic, but also with other customers as well. And I wanted to ask you both a little bit about the change in culture. That tends to come up more in like AI business talks. I actually want to bring it up in a technical talk because I think it's incredibly important. But what kind of things did you have to do for learning purposes as you're integrating these, or even just value proposition of some of these AI technologies? Can either of you dig into that?
The first thing that comes to mind is that maybe from the perspective of someone who's not technical or who doesn't have a technical background, they look at data as just data, and we analyze it and then we get results. But from a different perspective, or let's say from a knowledge management perspective, there are different layers, and I really like to show this as a pyramid, where at the bottom we have data, and from that data we extract information, and from that information we model it into knowledge, and that's key. And based on that knowledge, at the top of the pyramid is the wisdom. That's knowledge that combined with human intelligence. So one of the culture changes is to differentiate between data and knowledge, and data management is different. Is different than knowledge management. It's still data in a sense, but what's different is how, as a user, we engage with it, and how often we update it. How do we store it? What's a golden record? What's data that needs processing, and so on. So without getting too technical in it, there are culture changes within the technical community as well as in the business users to differentiate between different stages of data, so to say.
Yeah. And how about moving from proof of concept to production? Kakila, can I come to you for that one and just say what were some of the things that maybe we don't show in a 15-minute inspirational session that you actually have to focus on when moving from proof of concept, or how did you make that decision in some senses?
So we had a couple of proof of concepts with, using Azure Cognitive Search. And I think in the end, we took the high value user stories, whatever we think is important to deliver. And then, once we took that and we saw the results, putting it into production is just a matter of, deploying it in multiple environments. So yeah, I mean, that's we are in that process right now. So it's a journey, but it's a good one. Yep.
That's fantastic. And yeah, the word journey is super key there, because I think one of the things, and Marta, you might want to jump into this part as well. One of the things around AI, right, is it's just like any other code. We have to maintain it, and we have to keep it updated, and we have to retrain it. Marta, what are your kind of key points that you share with people around retraining and keeping models fresh?
Yeah, and it's a very important question that I get from a lot of the apprentices, because they build some things very cool, then that about how that they're going to actually maintain it and then continue that in a production environment, because it's a very different thing, as you guys were all saying. So it's how thinking. The biggest tip that we give them, or I think the most you think about it from the start, when you start building your model, how are you gonna make sure that you have in plan the production and the maintenance of it? How are you gonna think about, is your situation changing as much that you have to retrain the model so the parameters need to update? And then how to set that up from the start, because if they build something based on a static view of what they see today, and they haven't considered is my scenario going to be changing very often, very little, and then kind of going from there and starting thinking about modeling from that very initial step of what's my premise here, and then your model is going to be very, very different depending on which path you go on.
No, I do like that. It's a really good point. Marta, we'll come back to you just one more time. Gary, let's come to you on conversational AI. I feel like there's always a million questions that come up on conversational AI, and we never have enough time to answer them all. I was wondering if there's anything that you can share with some of the new stuff that's happening right now on your team.
Wow. Yeah, so we're getting ready at the moment for our sort of next semester, our next 6 months worth of effort on Composer and the Bot Framework SDK. Without revealing too much, I think you're going to see continued, as we talked about before, continued convergence between PBA and Composer. We recognize it's a an incredibly important scenario, and we want to make sure that there are simply no cliffs, right? Wherever you start, you have a route. The most frustrating thing to a developer is when they hit a wall and they realize they have to go and rebuild something because that wall is, almost artificial. So that's definitely one thing we're looking at. We're continuing to turn the crank on the skills scenarios as well. But I think most exciting for me is the idea of packages within Composer. So this idea that you can take some conversation flows that you've designed inside of Composer, or some custom actions that you've built, which you can do today within a single project. But we're actually going to make it possible for you to package these things up and publish them to the web, so that you, in another bot, if you reuse the same set of dialogues for date disambiguation, for example, or handoff to a human is something I've been focused on specifically, we can package this up and you can enable it in a couple of clicks on a bot, rather than having to try and manually reshare the code across projects. And I think this is hopefully going to mark another shift for us, because we marked the shift from SDK to designer, and now we're going to be able to rapidly take those assets and share them across multiple projects, just taking the time from 0 to productive to as little as possible.
Oh, nice. That's really, really cool. And it's always good to hear kind of what's happening, what's the focus of what we're doing, etc. Gary, can you tell us a few use cases? Because obviously we covered that Tailwind Traders kind of HR piece, but I know that every time we have a conversation, there's always like another use case that's kind of top of mind. What are some of the biggest use cases we're seeing that people are building bots for?
Yeah, so I think, we covered very much in the session the productivity use case, which is huge, especially at the moment, given the, the current world circumstances. But, really, anywhere that you interact with a computer today, or you interact with a human, either via text, via a messaging platform, or via speech, there's a use case there. So we see a huge amount of demand in the e-commerce and retail and customer services space. The ability for, if I go to my telecoms provider today and I go on their website and I go to live chat, more often than not, I get a message saying you're 12th in the queue and it's going to be 20 minutes. But a really good example of where we can actually aid that is, firstly, you could put a bot at the end of that chat to triage those incoming requests from users. Maybe even answer their question using the same technology that we saw today, things like Q&A Maker and Lewis, to understand their intent, maybe be able to answer their question, maybe route them to an automatic process within the bot. What you're going to do then is you're making the employees behind the scenes more productive. You're also improving their, quality of their job quality, because they're not dealing with the same mundane requests over and over again. They're just dealing with the high value and really more complex queries. But from a customer perspective, it's a dramatic improvement, because you're not sat there waiting to speak to someone. You can be serviced immediately. And if you do need to wait, you're going to wait less time. So definitely customer service and retail. We've seen an explosion of bots that handle things like mental health awareness and helping you on a day-to-day basis, checking in with you, offering some advice. And I think more and more we're going to see examples of that, both via text, but also via speech. We spoke about Google and Alexa before. I think they're going to be, home assistants, and really bots everywhere is probably where we're going.
Oh gosh, no, that's really, really, really good to hear. Amazing. So we only have a couple of minutes left. Apologies, just hold on 1 second. Yes, yeah.
Just real quick, if it's okay, I just wanted to come back to the product, because I've got quite a practical example that might be helpful to the audience.
Yes, please do.
So for us, the big lesson, I guess, was making sure we accepted that the AI was, it was going to be maybe 95% good, but it wasn't going to be perfect. So we needed to make sure we built that we've talked a lot about a feedback loop. So we built that into the product. So in our particular case, we've obviously got a conversational AI running on the customer's behalf, and users are engaging with that and asking questions using Q&A Maker and Lewis. And in the instance where we can't provide an answer, we record that and we communicate that back to our customers so they can say, hey, someone's asked this question. We weren't able to give them a response, and maybe we make a few suggestions saying we think maybe it was this one, or this one, and they can just go ahead and click yes, it was this one, or yes, it was this one. So again, it's really accepting it's not perfect, but taking the value that it gives you and then making it really easy to maintain that engagement with the people that are managing the content. So I just wanted to kind of throw that in because hopefully it kind of ties the examples that we talked about earlier.
Absolutely. And we are actually very slightly over time, but Marta, just very quickly, you, towards the end there, we saw getting into data science. You have trodden this track already in your career. Do you have any advice for people who got excited about that last session and went, actually, this is the place I want to be?
Yeah, I think we touched a lot of it in don't get intimidated. The first thing, it's all a lot of words and a lot of buzzwords, and you hear it in so many different places, but it's an incredible journey. Don't feel like you have to have all these titles that people get really hung up with, I don't have a master's, I don't have a PhD, I don't have this, I don't have that. And start small and continue building up on your experience. And something that I encourage a lot of all of the experiences, apply your learning, find opportunities to apply your learning, find a little project. And this is how I started. I remember, Amy, the conversation with you, and I had all these ideas. I'm how do I do this and how do I do that? And when you get to try all the packages that are available for you to start getting into that, oh, this is what machine learning does and this is what data science is. And then once you get to the point of can I modify this, can I then customize this, then taking the project to where you feel confident enough to continue improving by yourself, and then exploring educational alternatives that there are plenty out there. But my biggest thing was not to be intimidated by it. And I had great advice from people like you, Amy, that were it's actually not that bad. It's actually quite a simple problem that we're trying to fix here. And then using all the tools that you have available and have fun. Because if you're going to embark on a data science learning, just have a lot of fun while you're doing it.
Oh, brilliant. That is such a great way to wrap all this up. Thank you, Marta. Thank you, Willem. Thank you, Adelina. Thank you, Kakila. Thank you, James. And thank you, Gary, for joining us as our experts for today. We have covered so much. All of the links will be available for you at the end. Thank you for asking all of your questions. And from us, we hope to see you again soon. This has been Tech Days, a developer's guide to AI. Thanks so much.